the first workshop on maps for the web, week 2, day 3, and we are going to record this, and I'm going to start over. Sorry, Ted, I don't have recording permission, so I'll let you. Oh, it's already recording. Very good. So moving on. So today's theme of talks is going to be advanced web graphics for mapping, and followed by a stakeholder panel on commercial mapping services, and then we'll have a breakout session on collaborative web mapping by Karel Charvat and his team. And I'd just like to remind you that we have a Gitter chat channel open all the time. So that's a good place to have threaded discussions about ongoing topics. And the presenters will certainly welcome discussion. And after the presentations today, I will create discourse topics in the Web Incubator community group for each of the presentations to so that we can comment on an ongoing basis there about web mapping. It helps to gain attention to the topic of web mapping in the browser community. And I'd like to remind everybody that the workshop is conducted under the W3C Code of Conduct, which is linked from the each workshop page. So with that, I'd like to hand over the presenter controls to Iván Sánchez Ortega of the Leaflet community, who's going to give us a presentation on map adventures in weird web standards, gyroscopes, texture cubes, and mutants.
Yep, that's me. Perfect. So I won't be there too. Okay. So, hi everybody, this is me, Iván Sánchez, with one run to talk about joysticks, texture cubes, and mutants. I had to change that for reasons that will be apparent a bit later. So, for those who don't know me, I am a nerd. I have been doing these vector maps on the web since literally 15 years ago. I know a bit of stuff. My allegiances are towards OpenStreetMap. I have been a member of the board of the foundation a few years ago. I am a charter member of OffGeo, and I am a maintainer of Leaflet. I am very skeptical of this proposal. So skeptical that I cannot tell you why in 15 minutes, so I wrote a lengthy essay about it. It's my position statement as well, so please read it if you have the time. Since I have little time, I'm going to focus on this part of the joke. I don't think that the MapML standard covers use cases. I know this because I have been dealing with approving Leaflet plugins for a while, and they are literally hundreds. Each plugin is a use case, and I don't think the standard as it currently stands is able to cover all these use cases or even to accept the integration needed to cover these use cases. Since I'm really short in time, I'm going to focus on integrations with existing browser APIs. In particular, 3 browser APIs that you probably didn't know that existed, which are the Gamepad API, the text storage 3D from WebGL 2, and DOM mutation observers. So let's get on with it. Joysticks. How do we interact with maps? We do motion JavaScript, pointer events, we do keyword events. We also follow the user via geolocation API. We also rotate the map when we are navigating with the compass orientation with relative orientation sensors from the sensor API. We can also do an experiment about tilting a phone and tablet and then making the map slide off the surface of the phone and tablet via the absolute orientation sensor, which I didn't really have time to prepare the demo, but you can also do joysticks via the Gamepad API. And moving things with a joystick actually works, and it works nice. It's easy to do something like this. You just hook up the new events and works. And it's an interaction that nobody really has been thinking about. Works pretty well with gamepads as well. And I have to say this feels good. And I also have this feeling that interaction with joysticks or gamepads, it's something that I don't know what it's useful for, but I feel like this is really useful for something, even if I don't know what for still. So this has hooks to haptic peripherals. Maybe we want that. Maybe we want some accessibility features because some people might handle a controller better than keyboard and mouse. I don't know how that would work. And I don't know how this kind of interactivity belongs or works with MapML at all. One of the things I'm not sure about. I'm going to talk now about texture cubes. So back when I was 2017, I was doing some weird experiments, replacing the images from tiled maps with canvases, and each canvas receives a buffer from WebGL, and then you handle the textures, and instead the tile goes through a whole process to basically change the color. And I had this feeling of, this is useful for something, I don't know what for, but this has to be useful for something. So one of the things I learned, and this is important to keep in mind, is WebGL or OpenGL is not a 3D engine. It's a 2D rasterization engine that takes a lot of four-dimensional vectors, combines it with buttloads of linear algebra, and uses images textures. And before the code of conduct police comes to me, I'm referring to buttloads as the unit of measurement of alcoholic beverages, which is, in my opinion, what one person needs to really understand what the hell is going on in all that linear algebra. Now, a normal person will think that a texture is just an image, a color image, 8-bit, red, green, and blue, and that's it. For instance, people who have been working in video games know that textures can be more than images. You have something like the BAM map, or specular map, which is how a surface reflects the light that goes into that surface, and that can be put as different formats, 556 bits, 16 bits, 422. It's not necessarily RGB. Then when you come to learn what the GIS nerds from Earth Observation are doing, for them, raster data is temporal multispectral thematic data, which is a lot of tiny little squares and or cubes, which each holding 16 or 32-bit samples, one or more samples per pixel or per voxel. The breakthrough is realizing that the GIS raster data fits natively into GL textures, and I'm impressed that nobody has noticed this before. So you can just get data from a geotiff, put in a texture, and then you get the texture, and that will get the native data, the raw data with no transformations from that geotiff file. One of the nicest things about GL2 is that you get float32 format, and you get actual data cubes in the form of 3D textures. So in this example, I'm getting, this is pseudocode anyway, but you get the idea. I can get several samples from a GeoTIFF file, and since they are packed together one after the other, they will have the same format or the same data structure that 3D textures need for this. And then you just fetch them in the shader, and then you can fleet coordinates. You can use, in this example, I will be using just the different channels of an image, the same samples of a GeoTIFF file as the set coordinate, but you could easily change this and handle the coordinates with a buttload of linear algebra to do axis changes or whatever you want. One example that I have been working on is this one with some Sentinel data. In this, I have an actual data cube per tile. Each of the 256 pixels tile, it's not a tile, it's a small data cube, 256 by 256 by 7. So I can fetch textures from any of those points. I can do linear interpolation between the bands, I can do all that kind of stuff. And I can do something that is really nice, which is real-time raster processing and analysis, which is, for me, it's just beautiful, and things like this. I don't know what I'm doing, but I'm doing it real-time on the GPU with raw EU in 16-bit geodata from actual Sentinel satellites. This is great. I want to throw some buzzwords at you because I feel like doing this. It makes me a cool person. This is real-time, meaning it happens once per frame, which for normal people it's real-time. For electronics people it's not real-time, but it's a different discussion. This is real-time GPU accelerated because it happens on a graphics card. It's cloudless because it doesn't depend on this cloud of servers which are somewhere that you don't worry about. It's edge computing because it happens on the user's computer. It's for cloudless MRGA because you can apply the algorithms for removing clouds from Sentinel data or from multi or hyperspectral data. And one of the issues I think this has is that it's difficult to monetize because with cloud computing, it's really easy to know how many CPU cycles you have been selling to the users, but when stuff happens on the user's computer, you can't really measure how much work the user's computer has done using your code. So there's not a lot of money and people involved in this kind of research right now. Anyhow, I do predict by that in 3 years' time, every GIS person involved in Earth observation and raster analysis will ask themselves, how did we not this sooner? I don't know how MapML will work with this, and seeing the performance of GL and having seen how the low-level data abstractions work, I do not know how can we squeeze this thing. I do not know how can we make non-3D GL more accessible to any other developers, because GL has a lot of potential for raster analysis, and we're not squeezing it. I think it's because of the APIs. Whenever we talk about WebGL, we are already thinking into 3D and 3D models and a camera and an object and light sources. How can we change this perception? Because if we change this perception, I think we will improve raster analysis and any other kinds of sciences. I don't know. I want to make this happen. So I don't know how to get rid of the preconception that we should use SVG for doing graphics. I don't know. I'm unsure. I'm going to jump to part 3, so mutants. And I'm going to start with this fact that I am not going to accept any discussion on this fact. Leaflet users want to display Google Maze maps. They want to. This is a fact. Now, it's easy. You just put this title definition and it works. And you have to do nothing else than, one line of code. It works. But Google doesn't want you to do that. At least if they didn't, as of 2018, with this wording of the terms of service, you might not access map tiles through interfaces that are not documented or that you don't have access to. The wording of the current terms of service is not clear. So I know that Parsons is somewhere in the room, so can I have a clarification of this, please? Pretty please, with Silver on top. Anyhow, how do you overcome this limitation? What you do is you get a leaflet on one side of the screen and a Google map on another side of the screen. You hook them up, so whenever you move the leaflet map, the Google map moves. Whenever you zoom the leaflet map, the Google map moves. And then you do CSS trickery. And it works. It kind of works. So right now you can do leaflet with some Google base maps, but there lags. There's a lot of lagging. There's a lot of lagging when you're moving it because the Google map will lag at least 1 frame behind, and when you're zooming, some easy animations do not follow the same function, so stuff gets not really user-friendly. So you can overcome that by doing DOM manipulation, which is even dirtier. So you make the same thing, you hook them up so whenever the leaflet map moves, the Google map moves, and then you manipulate the DOM to steal the tiles. And it works. And now the tiles are in the leaflet container and there's no lag because the movements are controlled only by leaflet, and I don't care what the Google map might be doing with their now empty tile containers. You have to re-steal the tiles anytime you move, and there's a lot of race conditions because this is all asynchronous because it depends on the network, and then you have zoom issues, so the asynchronicity is hard and you don't know when new tiles will come in. So you can use mutation observers. You do create a container for the Google map, then you attach an observer and you get told whenever any DOM element is created inside that. In that way, you can automatically steal the tile to your DOM fragment whenever the tile is ready. And it works. And it works pretty nicely. So it just works. And obviously, there's the same CSS trickery to get the logo on the bottom and stuff like that. But it works, and compared to the leaflet native geometries, there's absolutely no lag whatsoever. The zoom is perfect. It just works. Now, this has been called, and for me this is high praise, absolutely brilliant and terrible at the same time. And I think so. This is something that shouldn't exist. and this is to be one of my hard points of view, might be controversial, but this is one of the hills I will die on. Vendors should be able to exposing standard interfaces. Authors should be able to cache all the map assets. Clients should be able to exchange those map assets via P2P, because one of the excuses that we have been given for paying for maps is that there is a cost associated with it. If it goes peer-to-peer, that cost would go down. So that's something that for me is quite important. I also think that DOM mutation observers shouldn't exist. They break the encapsulation of code in web applications, and it's just dirty. It allows very dirty hacks. And Google Mutant, as a whole, as a concept, it shouldn't exist. I shouldn't have to spend any time making it. Really, it has no reason. There should be no reason for it to exist at all. So one of my biggest complaints or critiques about MapML is that MapML shall not fix any of this. MapML will not make vendors expose to standard interfaces, will not author cache map assets so they can control all the things that they display in their web pages. It will not let clients P2P exchange map assets, which would be a boon for everybody. It will not deprecate browser APIs, because we only put more and more and more and more in browsers. And it will not stop people from doing ugly hacks. That's my main point about why I don't like MapML, or very condensed in this short talk. And that's what I have. Please read my essay, and that's it.
Well, thank you, Iván, for that exciting tour of your thinking on the subject, and I've put a few comments in chat. I'm happy to engage on those. So with that, we're going to move on to our next presentation, which is Map Compositions Format by Karel Charvat. Sorry, I think that's my video started. Karel, over to you. I think you're on mute.
Do you see?
Oh, yeah.
Hello. Thanks to give us chance to make our presentation here. Now, in this short introduction, I will only make some short messages about what we are doing, and to the detail we will present it later in breakout session, where my colleagues Runar and Raitis will give you also more technical details. As Iván before spoke about things related with leaflets, we will now move to other technologies, more to open layers and QGIS. But at the first, I will tell about what and why we are speaking about map composition. What Iván presented, it was mainly focused on some expert work with geographic information. But what is clear? Oh, sorry, what is? But why it is not working? I'm not able to move with my image. Sorry. I have problem to move with presentation. I don't know why.
Are you sharing it off your desktop or from the web?
No, I'm doing this from my desktop. Yes, but what is
well, maybe exit presentation mode and go back in.
When you moused over at the bottom boundary, I was also seeing a next and back button too. At the bottom, move your mouse to the bottom of the presentation. You're hovering over the end. I was seeing some buttons here.
Where are buttons? I don't see.
If you move further down, move your mouse further down.
No. Here.
There you go.
Okay, here. Okay, sorry for this. So Why we are speaking about map composition, and we will speak also not only about map composition, but about cooperation. If you are looking on the classical map, yes, there is a number of different information. Now with geographic information systems, we are dealing with layers, yes, but layers are not map. And what is important for people who are not expert to move from layers to maps, and we opened this first time when we developed the check in Spatial portal. It was around 2010. Here you can see on one side how looks some maps, on other side, if we are looking on the data, it looks approximately such. But we have to move from this layer paradigm to paradigm of the map. And first time we work about this when we implemented this in Spatial portal, and in this time we start use web map context. It was in the past some OGC standard, but with some limitation, and this limitation was mainly that it worked only with WMS services, and there were no possibility to integrate other data. But we extended this in this time a little, this concept, and on the check-in Spatial portal we start to offer to the people thematic maps, not layers, but non-expert was able to select some concrete composition of the layers and work with this, because for many people it is very difficult to understand WMS, understand other things, and also decide it in which scale you have to put which layer. So this could be or has to be in some way described in this map composition, or what we are now calling the maps. You can see here we have a number of layers, but on the end we need to have the maps, for example this combination of the satellite images with OpenStreetMap or other. And we have now a huge number of new technologies, HTML, CSC, JSON, and it is important to use this technology how to describe map. We developed our own JSON format for describing of map composition. Later in the evening, Raitis will tell you about this. And I think that today meeting is also a good opportunity how to discuss and speak how, for example, this approach which we are now pushing can be combined with other effort and other standard in OGC or in W3C. And having here my colleague, I think that it is a good opportunity to start discussion with other how we can combine this our approach, which is now used very often. We implemented this approach not only for open layers, but we are able to share maps with QGIS, and we start also some tests with leaflet. So the idea is that the map is defined and could be shared on other places. Yes, like you are now sharing music, you are sharing other. You can have the silos, and you can from the silos be able to share the maps. The silos could be some map catalog, not only catalogs for WMS services or other, but to have the catalogs, also the maps, and to be able to share with other people the maps. Second things what we will today speak much more is what we are calling now Map Whiteboard. What is it? You are probably all working with Google Documents. Google Documents is something where you can share the text, and many people can edit this text parallelly from different places, and in collaborative way you can work with the maps. It could be important for many applications, for education. It could be good for farmers. It could be good in crisis management if you are able to share the maps. You are able to share all layers. You are able to share your drawings immediately, and other people can communicate with this. Of course, this is now more and more important in the COVID period to have real collaborative work, and this is what we are now working and what we will speak. As I mentioned, there is many application where this could be used. Of course, in education, typical place could be spatial planning, it could be agriculture, to be possible to share the maps and to edit the maps collaboratively and to share these maps with other people. So this is some short introduction, and I hope that some from you will be able to stay till the end, and we will be able to explain you in the detail what is our map composition and what is this map whiteboard. Okay. Hello?
Sorry. So thank you very much, Karel. We're going to move on to Daniel Morrissette, who'll be of MapGears, who'll be talking about the implementation of MapML in MapServer, GDAL and OGR. Over to you, Daniel.
Thank you, Peter. So my slides are on, right? I assume so. So we'll talk about the implementations that we put in place in MapServer, GDAL, and OGR, essentially kicking the tires to see how it goes with the current draft version of the spec as of the spring. Okay, so for those who may not be from the GIS world, MapServer is a web mapping engine, open source web mapping engine. The GDAL library is I guess the Swiss Army knife of GIS. It's a library that supports hundreds of raster and vector data formats. And both are open source projects of the Open Source Geospatial Foundation. So the stuff I'm going to talk about today is implemented and available as a reference implementation in open source format. First, for the case of MapServer, there's a link to the documentation there. It's been discussed in MapServer RFC 123. It's going to be included in the MapServer 8 release. At the moment, it's available through a GitHub source fork, but the implementation, it's going to be released later this fall. Essentially, for those who know MapServer, you've probably all already published a WMS, an OGC WMS service. So all you need is a WMS-enabled map file that you've got already. You enable the get MapML, a new vendor-specific get MapML request, and that's it. The rest is magic, handled by MapServer and the polyfill viewer through the MapML spec. So essentially, in your map layer tags, the MapML layer tags, you include a custom URL, which is service equals WMS request equals get MapML, and then you specify which layer you're referring to from your map file and the projection using the projection code, the MapML projection code. So essentially, it looks like this in the HTML. And so this is the actual source code from an example. And I'm gonna swap to just to show it in action, just to show that it's a real thing and it really works. So this is, by the way, this is the documentation from the MapServer side. So it talks about the metadata elements, the configuration elements that you can use to control the behaviors. And essentially the viewer looks like this. So it's just a simple leaflet. Well, it's the polyfill viewer that you're seeing here, pointing to a WMS layer. So the source code of this page is this, with this get MapML URL pointing to the MapServer map file. And if you look at the source of what MapServer returns, it's a MapML document. So, implementing the draft specification, which contains link rel equals image. So full screen image maps are requested using this URL template. And for the when you query the map, so the link rel equals query points to get feature info using the template. So all this, this is a bit verbose, but it's all handled by MapServer. You don't need to do any of that. Really, all the all you need to do is create this layer element in your HTML to make it work and have a MapServer, a WMS enabled MapServer map file. So back to the slides. Yeah, so that's what I talked about. There's so the case I've been showing was the link rel equals image, which returns a full page WMS request, but the implementation also supports tiled requests. So you can request tiled WMS request, or there's a custom mode in MapServer, which is mode equals tile, which mimics, I believe, the Google Maps API tile request. So that one is supported as well. There is a future plan to have the ability to do a WFS get feature using link rel equals feature. And as I mentioned earlier, link rel equals query will point to get feature info, to WMS get feature info to allow you to query the map. So that's it for the MapServer implementation. Now, for those who like to work with data or would like to generate a static data set and host it without any server-side components, an implementation has been made as well in GDAL for the raster side and in OGR for the vector side. So as I said, the GDAL library support hundreds of vector and raster formats. And what's been done on the OGR side, that's been added recently in OGR version 3.1, which was sometimes in the spring or the summer. The documentation is available at this URL. So it's part of the, it's a MapML driver, essentially, an OGR driver. And it will read and write MapML vector features. So it reads its own MapML. It will not read any MapML because there could be too many variants, but it will spit out MapML output. And the comment for those who are familiar with the OGR to OGR syntax, which is probably not too many people because it's very cryptic. Essentially, if you were to use it with OGR to OGR, you would specify, let's say, in this case, I'm going from a point file, which is a shape file. I'm creating a MapML file. And I'm running an SQL query on it to just select some attributes I'm interested in and only select, say, the populated places of more than 100,000 people. And I'm passing some custom contents for the HTML header, for the MapML header in this case. So that's the way to do it on the command line with OGR to OGR, for those who are familiar with that, or just export to MapML from OGR enabled software. And about any piece of GIS software does support OGR, so that should make it fairly widely available. Then you will refer to this MapML file from your layer element in the map. To be fair, I have had some glitches with the current polyfill trying to do that, so I need to do more tests and probably go back and forth with Peter on the implementation. But the implementation in OGR does produce the valid MapML. And then on the raster side, the GDAL to tiles utility, which can be used to take a raster image and generate a tile pyramid, and it already supported the KML output, so it's been extended to support MapML output. So essentially, when you run it, it will take a raster image, create a tile pyramid, a tile set out of it, and then create a MapML header file that refers to it that you can use to host the data afterwards. And the command looks something like this. So it's a command line utility in that case. So, and then you take your output folder and then place it on your web server to host and refer to it from your map element in the HTML. I have to say that the implementations in GDAL and OGR were done by Evan Rouault, who is the maintainer of GDAL and OGR, so he has to be thanked for that work. And that's about it. So the quick introduction. So 3 implementations. I know there are more. GeoServer has an implementation as well that's been done. And there's a few others that maybe Peter would be better than me to list, but there's a few reference implementations. So that's, I guess, a good way to start to see the MapML in action and see how it goes.
Yeah, great. Thanks a lot, Danielle. Anyhow, it's great to see MapML being incorporated into these mainstream open source tools, showing the web platform community that we are serious and intend to meet them halfway. So what we're trying to get is them to come out of their houses. Okay, so moving on to our next presentation, we're going to have a lightning round from Andreas Hocevar, the Open Layers project on OffScreenCanvas for rendering performance. Andreas, are you ready to go?
Ready to go. Thank you.
Your audio is a little choppy right now. Don't know if there's anything you can do, but anyhow.
Turn on screen sharing.
Yeah.
So I'm going to talk about a way to improve rendering performance of huge vector tile data sets in OpenLayers. And I guess this topic might be of interest because as long as MapML is not available in mainstream browsers, mapping libraries will have to provide their own renderers. And the goal here is of a project that was funded as part of the Maps for HTML effort, which I'm very thankful for, was a proof of concept to improve rendering performance and avoid blocking the UI in OpenLayers. For those who don't come from a web mapping background, OpenLayers is a library for creating interactive maps on the web, and it can display map tiles, which can be raster tiles like the ones that Daniel was talking about, but also vector tiles, also untiled vector data and simple markers loaded from any source on any web page. And this can really be a huge amount of data. Later on in this presentation, I will be showing a vector tile data set where a single tile, which covers no more than 512 by 512 pixels on the screen, can be more than 500 kilobytes, which translates to tens of thousands of vectors. And unfortunately, the makers of OpenLayers, which include myself, are not as smart as the makers of Mapbox GLJS, which has a super fast and performant and good looking WebGL renderer. In OpenLayers, rendering is done using the Canvas 2D API, which means the GPU cannot be leveraged to such a high extent. And this is also the reason why such heavy maps, as I just mentioned, can cause slight performance problems. So what is the problem? A typical rendering pipeline for a web map consists of loading data, parsing data, rendering the data, and then, of course, the user interacting with the data, which means zooming and panning the map, querying attribute information, and things like that. With the standard browser APIs for asynchronously fetching data, loading already runs without blocking the UI. So in these graphics that I'm going to show, each row represents things that have to be done in parallel. So in a standard OpenLayers map, loading can happen in parallel while other tasks go on, parsing, rendering, and interacting with the data. Loading the data is not the problem here. It gets interesting with parsing data. The more data you have, the longer it takes to parse it. But the real bottleneck with a Canvas 2D renderer is the rendering process itself. OpenLayers is also very flexible with rendering. It allows you to style your map, your vector map, with functions that can look at each feature and decide based on that how to render the feature. So it's very flexible here, and it's all in this context is also not easy to prepare that data in a way that a GPU can run it in a parallel way that would give a huge performance benefit. That's also one of the differences to Mapbox GLJS, where you have a styling language and not arbitrary style, JavaScript functions to style your data. So one thing we could do would be to use the Web Workers API that's available in all modern web browsers. This would allow us to load and parse data in parallel and in one thread, and to render and interact in another. The problem here is that transferring data between a worker and the main thread is only efficient with structured data like typed arrays. And at this stage, we don't have that structured data already. We still have vector data that could be different types of geometries, and we have to combine them with styles that are still JavaScript functions. So we cannot really create a typed structure that can be efficiently transferred from the worker to the main thread. So one solution to that would be the use of OffScreenCanvas. That's a new API that's already available in Chrome. And what I'm going to show now is a proof of concept of making use of this API. By using OffScreenCanvas, we can also put the rendering separate from interacting with the map, which as a consequence results in no more blocked UI by heavy calculations going on. So we can load, parse, and render the data in a worker. OffScreenCanvas allows us to prepare a canvas in a worker and transfer it efficiently to the main thread where we interact with the map. Now, let me show you how that looks when we apply that technique. In this video, I'm going to show on the left, you see the use of OffScreenCanvas, and on the right, you see the same map rendered with open layers without any workers. And this is the data set I talked about, where just a single tile can have tens of thousands of vectors. So this is how it looks. As you can see on the left, everything smooth. The only delay comes from loading and parsing the data, but the UI is not blocked. And you see on the right side how the UI is stuttering as this automatic animation that zooms and pans the map around is going on. So why don't we use this by default? As I already mentioned, it's already available in Chrome, but that's about it. So it's available in the Blink engine, which is now also used by Microsoft Edge. There is limited OffScreenCanvas support in Firefox, but only for WebGL contexts, not for the Canvas 2D context that we use in open layers. And it's hidden behind an experimental flag, so not available to the average user. And it's not available at all in the WebKit engine, which is used by Safari. So this is, please, WebKit and Gecko developers implement OffScreenCanvas. When this is available in all mainstream browsers, we can provide good performance improvements, and it will make it easier to wait until browsers have native map rendering available with MapML in a hopefully not too far away future. Thanks in advance, WebKit and Gecko, for implementing that, hopefully soon. And thanks again, Maps for HTML community, for funding this effort that allowed us to explore the benefits we can gain from using OffScreenCanvas in open layers. Thank you.
Thank you very much, Andreas, for your contribution to the community. And hopefully we'll get some attention for those features in Safari and Firefox as a result of your efforts. So moving on to our next presentation, we're going to hear about dynamic and observational spatial data from Thomas Usländer, Hylke van der Schaaf, and Katharina Schleidt. Have I pronounced that correctly?
Schleidt is correct.
Good.
Yes. I'm presenting. Can I take the screen?
Please do.
Got it.
Share, yeah.
Is that working?
Yep.
Yeah.
Okay, so we're going to start filling some of the gaps which have been showing up in today's presentations. I admit I noticed the word sensor being there and suddenly going away. So now it comes back big time. What are we talking about? I mean, it's various dynamic data in a spatial context. We start with how we provide a basic attribute. So in normal worlds, you've got some object, you have two characteristics of the object, the color, the expression. These are simple attributes pertaining to the object, and they have values. And everything is fine until you start realizing you need additional metadata. So that's why we've got the observational models where you realize, okay, yes, I know the color is yellow, but by what methodology, how was that used? What could the colors be? What is the data quality? All of this information is missing with simple attributes. And we need this with measurement data. The problem is when you get confronted with a pile of these, it is not easy to play with. And so the users get this, they look very confused. What they really want is this. They want nice, simple, flat tables they can stuff into their R and get on with it, or some simple way of mapping, but not the holy mess. So they have the simplified world, but then they start realizing that all of these additional bits were relevant after all. And then they're not happy anymore. And this is where we've been making good progress with sensor things technology, because it really allows us the various different viewpoints on this. The only problem is, how do we get this onto a map? So a short background of sensor things, since I'm aware this community is not familiar with this. It's a technology that was introduced by OGC 2016. It comes from the IoT world. It's a wonderful standardized way of representing sensors, actuators, also simulations, and it's built on a long history of OGC standards dealing with what they refer to as sensor web enablement. That's essentially determining how can we get this type of dynamic sensor measurement observation data sanely connected with maps and spatial data. Relevant domains to which this is being applied. I mean, it's used very strongly in the environmental sector. It's also used in building management systems, smart cities. Industry 4.0 is going in this direction. But the more we've been working with this model, we've realized it's so flexible that one of our recent prototypes has been putting European demography data online, and it works beautifully. So it's really a very nice flexible technology when you've got dynamic data pertaining to your spatial objects. Okay, that's a bit of the history of it. I'll keep this short. What's it about? It's got a core data model in the background, which covers all of the concepts you need to really nicely structure measurement data. This comes from the background of it is the OGC Observations and Measurement Standard, which has been formalized as ISO 19156. That provides this basic core. It's been a bit specialized here for the purpose of sensor things, and provides, one has the resulting values, but one also has what was observed, how was it observed, where was it observed, methodological information, it's all there. But the problem is, okay, let me do some more explanation of this. It's based on the OASIS OData model. We've got various get, post, patch, put, delete. You can input, output all of your data. We've got various query parameters which allow you to really nicely deal with the RESTful interface. And we've got an MQTT interface in the back end, so we're totally suited for clicking on sensors, plug and play. The problem is the query logic. And if you think back to the data model I was showing you before, most simple spatial applications deal of individual objects with attributes and geometries. They do not have this complex structure between the classes. And this is essential in order to really access this data, because you need the pieces from the individual concepts. Thus, the sensor things query logic allows you to really you can formulate your queries based on the graph defined by the data model. And so this way, we haven't come up with a query you cannot formulate and nicely query. And what we want to do with this, I mean, here's an example from the Austrian air quality data. You want to put your data on the map. You've got your points where you have it. The problem is what happens if you have too many points. You need to put little circles with numbers. You want to get to the points, you want to see what is available there. The list here are the observable properties available from the station Bad Visslau. And then if you click on one of these, you want to see the time series of the actual values. This is what we would want, and this is what, at least until a few weeks ago, any developer who wanted to expose this data had to do manually. A further trick which we have there also pertains to multi-resolution data. If you zoom in, or if you're looking at a very coarse map of Europe, you don't need all of the details. The more you zoom in, the more you really need all of the tricky bits. And we see this nicely. There's an example from Norway. We've got on the left, we've got the sort of the big picture data, which vaguely finds the islands. On the right, we've got the very high resolution each fjord is in there. Sensor things allows us to cope with this because one spatial object can have multiple locations. And so we've made good use of this by storing all 5 different resolutions as locations, having a flag in the data showing which resolution it is, and the map viewer pulls the right resolution it needs. So what did we do to get out of this? We currently have we've been discussing what do we call it. It's not really a plug-in, it's more a plug-on. It's a small little JavaScript library which handles all of the tricky bits we've been discussing, be it how do you show the different resolutions, how do you alternatively show little pins for the individual stations you can show. If it's too many, just provide a number. You've got various integrated callbacks, so you can pre-configure it and say, when you click on the point, then get this callback to show the observable properties. When you click on an individual thing there, call that function to show the graph. It's available on GitHub via the link here. Functionality I've shown. Here we've got an overview of the configuration options. So I mean, it's basically one large, not even large, medium-sized JSON object, which you configure, fill out these parameters, fill out the parameters on the next page. And once you have this filled, you have to tell it, is it working with leaflet or open layers? And then it seamlessly integrates with whatever map software you have underneath, adds all of this functionality, everything is good. So conclusion, Sensor Things API is becoming increasingly deployed. More and more domains are covering the power of it. Map-based visualization has been the tricky point, and with our Sensor Things API map library, we think this is a good first step at providing simple support for this. More information, the work was done under the API for Inspire project, funded by the European Elise program. More information at the link I presented. Thank you for your attention.
Thank you very much, Kathy, Thomas, and Hylke. Very interesting presentation. So that's we're a little bit ahead of schedule, but that's good because that leaves lots of time to chat. And at this point, maybe I'll turn it over to Ted Guild of the W3C, who's going to moderate a panel for us today. So I'll pass it over to you, Ted.
Thank you, Peter. My name is Ted Guild. I'm the W3C automotive lead and also the staff contact for Geospatial on the web. I'm also part of the program committee for this workshop. Today we'll be having a stakeholder panel on commercial mapping services on the web from the provider's perspective. We're joined by a number of commercial map service providers who will give a partial overview of their current solutions, as well as both business and technical perspectives on specific challenges and opportunities they see for the global map community to consider as we seek to make HTML maps a first-class citizen on the web. Peter at the outset reminded us of the W3C Code of Conduct. And unlike Chris Wallace in his moderation of the US presidential debate, I will not hesitate to mute for people trying to speak over each other or trading insults. Bad joke, maybe. Anyhow, more seriously, I'd like to have this an open discussion, an open dialogue. And my role is just to try and facilitate the conversation, try and engage the various panelists to speak to each other directly, and when and where possible, I'd like to involve the audience in that as well. So with that, I'd like to introduce the panelists and going alphabetically by last name. We'll start off with Ed Parsons from Google. Ed is the geospatial technologist of Google, with responsibility for evangelizing Google's mission to organize the world's information using geography. He's a member of the board of directors for the Open Geospatial Consortium and was co-chair of the W3C OGC Spatial Data on the Web Working Group. Ed, will you please further tell us a little bit about yourself?
Hi, well, thank you very much, Ted. It's great to have two Eds together. Two Eds are better than one, as my mother always used to say. Yeah, I've been involved, I suppose, in geospatial for pretty much all of my career. I set up a original HTTPD server on an old Mac in my office when I was an academic many years ago. And one of the first things I tried to do then was to put a map onto a web page using the original map tag in HTML. And I've been trying, I suppose, to make geospatial information more mainstream, more usable ever since. I think we've done a good job in doing that up until this point in time, and I continue to do that in my job at Google.
Thank you. Next, we have Johannes Lauer from here. Johannes works as Principal Technical Product Manager within the Department of Content Engineering at Here Technologies, where community map making and map content ingestion are the main fields of his interest. Johannes, can you please tell us a bit more about yourself?
Yes, sure. Thanks for the brief introduction, Ted. I just have to look for the mute button. All right. Hi, everybody. So my name is Johannes Lauer. Yeah, as Ted mentioned, I'm working at Here Technologies. Before joining Here, roughly 5 years ago, I worked at Heidelberg University and did a lot of things about geographic data sets, OpenStreetMap, things like that, volunteer geographic information. And parts of my PhD was about doing sensor data analytics from agricultural machinery, building maps out of the movement and the telemetry data of tractors. So yeah, building the digital representation of the current reality into the map. All right.
Thank you. Next, Daniel Lewis from Geotab. Daniel is the senior data scientist working on smart cities projects and predictive maintenance projects. The data analytics team at Geotab. He is focused primarily on leveraging machine learning tools and techniques with geospatial data to create innovative products from connected vehicle data, ranging from congestion analysis to identification of road network changes. Daniel, will you please tell us a bit more about yourself?
Sure, thanks, Ted. So yeah, I come into this kind of conference as very much a newbie to geospatial data and maps. My background, my undergrad is actually in semiconductor physics and my master's is in biomedical engineering, so pretty far away from mapping technologies. And then through interest and happenstance, I ended up working in the telematics space where, of course, primarily almost all of our data is geospatial based, and been kind of on a rapid learning curve, getting up to speed on this mapsing, so it can bring a perspective from someone who's not ingrained in the field from the outset.
Thank you. Thomas Lee from Mapbox is currently the policy lead there, and prior to that, he was leading the engineering search team. His work includes extensive use of open geospatial technologies and standards, as well as engagement with projects and communities like Open Addresses and OpenStreetMap. Tom, can you please tell us a bit more about yourself?
Yeah, of course. Thanks, Ted. It's a real pleasure to be here. So yeah, as you mentioned, I've done a bunch of things at Mapbox. Yesterday was my 6-year anniversary here, actually. It's included everything from leading the engineering team that works on our search engine, to product work on the map side, to being head of policy for the last couple of years, which is focused on interaction with standards bodies and government. Before this, I was CTO at the Sunlight Foundation, which is a transparency-oriented nonprofit in the US that focused heavily on advocacy for open data, which is kind of the path that led me here. So it's been a thrill to learn what the geospatial world is like and how it connects to the larger world of open knowledge.
Thank you. So as I mentioned, I'll keep an eye on the chat window. If there's questions from the audience and I feel there's time, we'll take them now, otherwise I might save them towards the end. We have our esteemed panelists have a mix of experiences, backgrounds, in some cases veterans in geospatial area, and in others, including myself, new to this area. And I believe Daniel has much more experience in geospatial than I do. And what I'd like to see is what lessons people have learned in future of mapping on the web, and including sort of fresh perspectives, in case of people that are sort of new to this. Tell us a few things that you feel are worth sharing about where you see mapping now, where you think things we can learn from historically, where you'd like it to go. Since no particular order, if someone feels like jumping in, feel free. Otherwise, I'll just sort of call on someone, sort of ad hoc kind of thing. And as I said, feel free to sort of veto up, interchange and interact with each other as we go.
I'd be happy to jump in if folks don't mind. Go ahead.
Please.
I apologize to everyone else here. I had put together a slide deck because I totally screwed up trying to connect before this. I've got this whole thing loaded in my head, and I got to get it out, but I'll be brief. So there are three things that I want to try and convey to this audience in the hopes that it can inform the work that's being done by the group. The first, I think, is that there's reason for better senses of optimism about interoperability in the mapping world than I have seen in some of the materials presented so far. I have some blinders on here because I'm really proud of the work that Mapbox has done in the open on these questions. But I do want to underscore the fact that there is a universe of open standards, either like admirably open, they've gone through standards bodies, or just de facto ones like shapefiles that are sort of the PDFs or Word docs of the universe that everyone can read but isn't exactly happy about. My colleague Sean Gillies got GeoJSON through the IETF process. It's an official standard. The Mapbox vector tile spec is used by lots of organizations, including open layers like Andreas just presented. Is an open spec and available to all. And in general, I think that there is like a bit less of a lock-in than has been purported here. I would encourage people to check out the awesome vector tiles repo on GitHub, which lists a ton of different open projects and vendors that are using the standard. The second thing I want to focus on is just like trying to underscore the fact that maps and tiles in particular and the technology behind them are a classic pre-processing versus runtime trade-off. And people need to bear that in mind as we're considering technologies to address this problem of use cases. There's a baseline of basically 60 frames per second cross-platform performance, as well as bandwidth efficiency that have to be met if any work coming out of it is going to be relevant. And that does have to be cross-platform. I'm afraid we can't restrict ourselves to web browsers on desktop, as we might like. Raster tiles are at one end of this, where you can do a lot of pre-computation, but lose a ton of flexibility. Vector tiles are at the other end, and there are various points along the spectrum where you can make different choices. The industry is at vector tiles now, and I would strongly suggest folks, the raster tiles are still an essential part of the picture if we're talking about imagery base layers or some types of pre-processing, but they're not where the action is right now. And really, vector tiles and particular rendering on the GPU is where the industry is and where work needs to be done to push things forward. And then the final point I'll make is that I think there's a real important need for a batteries included approach to any proposal that comes out. Geodata is big. Our Mapbox Streets tile set, which is a small sort of highway use case oriented tile set that's like comparable to what you would want in your Google Maps application, is at least 400 gigabytes with terrain data closer to 800. And our satellite imagery layer is measured in petabytes. This is not stuff that's going to ship with a Firefox download. So thoughts need to be given to how users who want the ease of the HTML authoring experience and deserve it are going to get that. There is a need for some level of centralization for a sense of authoritativeness, for dealing with licensing across geodata. And in general, I think to make this maximally compelling, we've got to get beyond throwing a simple vector data set that fits in a GeoJSON file into a browser. It's unfortunately pretty far from where meaningful use cases are.
Thank you, Tom. We'll get to some more of that, unpack some more of that a little bit more later on. Ed, Johannes, Daniel, anyone else want to jump in on this one?
I don't disagree with anything Tom has said there. I think from an interoperability point of view, there are enough standards to make sure that the very kind of building blocks that we need to sort of build solutions now and into the medium-term future are mostly there. There's work to do. But I think sometimes we need to sort of step back and say, well, actually, what are we trying to do? What is a map fundamentally? Is a communication tool for displaying a particular message, to communicating something that's relevant to us, and that's going to change on a minute-by-minute, second-by-second basis, depending on the message we're trying to communicate. But it in itself is only a small part of the broader geospatial industry. And in many cases, the solutions for some geospatial processing might be a yes/no decision. It might be a cell that you put into a spreadsheet. If anything, we've learned over the last 20 years is that the geospatial industry is very diverse. Indeed, the presentations we've seen over the last week or so in this workshop have seen a huge diversity of different applications people are trying to do. So I guess my initial point is around focus. I think to make geospatial information on the web, in the browser, a better citizen, we might need to focus quite finely on a limited number of use cases where we get the sort of maximum benefit, because there's a huge breadth of things that we probably don't want to standardize at this point in time. But there are some core things, perhaps around simple static map display, that would give us initial early benefit and would allow us to move forward. There's just such a diversity here. I think that focus, that product management approach is really important.
Thank you. Daniel or Johannes?
Yeah, again, I can't really disagree with anything that's already been said here. And one of the things that Tom Lee mentioned, there's a lot more being done and exciting things than just kind of like throwing GeoJSON on a map. But that is a lot of what I actually do on my day-to-day work. But like having smarter, better ways to integrate that kind of data with the actual vector map tiles for our customers is something that I definitely want going forward. And there are cases where we need smarter ways to be able to do that, because even sometimes we're able to show, for example, the map representation of our customers' data in an anonymized way, but we can't actually share the data itself, and there's no easy way to do that other than just overlaying GeoJSON on a map. So having better integrated ways to dynamically generate that and such is something that I would be excited about going forward for sure. And then, yeah, again, I can't disagree with anything Ed has said as well about the dynamic nature of the space and the different array of products and applications.
Thank you. Johannes?
Yeah, thanks. So I'm completely aligned with all the speakers here in the round, and I think it's a super heterogeneous space where we are currently moving through. So I think it's just the peak of the ice cube that we scratched with mainly visualizations and some small things of mapping when you look backwards. So the whole thing about cartography, which has been made over decades and centuries, more or less. You see how you combine the maps, and now with the maps for the web, it is changing. It's getting more dynamically, but you need all these visualizations to represent the information, to have a better decision-making process, make that faster. And besides that, you're getting a super heterogeneous set of data, which is coming in that you need to process within a very short time and present this to the decision makers at the end. And I think there will be an evolution which will be, yeah, probably faster than it was within the last year. And the request for standardized inputs and an very maybe agnostic way of working with data and different data sets to represent this data to the whole heterogeneous set of decision makers, from politicians to engineers to researchers and so on, and also for software engineers to handle the data. I think it's quite broad, and we definitely need a broad set of tools for that.
So thank you. something that several of you sort of touched upon was sort of the openness of data. SAL exists from commercial interests, including your own, because costs are considerable. You want to sort of protect those assets, and quite a few of you your companies are finding ways to sort of open them up in various ways and forms, not just to customers, but for other purposes. We also sort of often hear of silos existing within organizations as well, where different departments don't even know how to open up and share data with each other. People take a very narrow, specific focus on a given problem and don't think about how to architect and engineer data for future openness and interoperability. I'd like to sort of hear some of your experiences in that, and part of it is also some of the benefits of opening data. I know that there's been several cases where people, some of the panelists companies here have been extremely helpful in helping various disasters. As far as opening data in real time, making it available for emergency responders and governments in order to sort of realize the impact and sort of really sort of target their focuses. As far as this is something we'll probably expect to see more of with climate change and all the various wildfires we're seeing an increase of. There's a lot of information that is being collected that can be harnessed and leveraged and shared in a very useful and meaningful way. So just in general, maybe a bit about experience with the silos, opening up the benefits for opening up, including what I was sort of mentioning as far as basically helping our fellow citizens of this planet. A little bit about your experiences and thoughts. Since Johannes had the pleasure of going last, let me call on him first, but otherwise let people sort of jump in. I don't know if he's squirming too much, but your camera's still on in front of me, so.
All right.
The last person speak,
yeah,
so.
I can start with that. And I would
Right.
start with a quite famous sentence, which you probably all know. So the whole thing is more than the sum of its parts. So when I think that's the motivation. So it's the sentence is from Aristoteles. It's quite famous. And if you're having in mind all these research projects, for example, within the European Union, you have, for example, this Horizon 2020 programs where companies, research institutes, NGOs, governmental institutions and so on are getting partly funded to do some projects together, which is partly research focused, more innovation focused, but also for building new ways of getting money, building new businesses and so on. So when you see how companies are working, so not having the whole thing of a solution for potential customers, but also being in one boat with several competitors and trying to find a solution. I think the cake of the geospatial stuff is increasing, and it will be increasing for the next years or even decades, because we are still in exploring the things. So I think together you will probably get more than you will get alone within your own business, and it will widen the scope. And with this interoperability is for sure one key part, and also within our panelists here. So there, at least two other competitors of here in this panel is where we have like the same fields of businesses, but I definitely think that every competitor has its own focus and specialities that we can bring in to solve customer needs at the end. And I think this is something that needs to be explored.
Daniel, Thomas, any of you?
Yeah, I can jump in there. I mean, yeah, interoperability is kind of like a key thing going through all of this, of course. I mean, you mentioned a couple of things when you were talking there, Ted. Also, I was told my mic is quiet, so someone yell at me if it's still too quiet. I'm just trying to go closer to it here. One of the things you mentioned was kind of like social good and that kind of thing. Like that's something that we try to do a lot of. We actually have a portal where we release a whole bunch of just open source data sets. I mean, there's a few reasons for that. And it's not entirely selfless. One is that like it's an interest and kind of like business draw, but also we find that like putting data out kind of builds up a couple of things. One is just like partnerships and ideas of like better ways to use our data and interesting things that we can do. Part of it is also just like, as you mentioned, there's disasters. So our devices that plug into vehicles, they've got onboard gyroscopes, accelerometers. So, when tremors start happening, we're able to measure that from earthquakes and vehicles. And when the Mexico one happened, I think it was last year, the year before, we were able to detect that and the aftershocks and stuff and pinpoint areas that were hit harder. And likewise with hurricanes and stuff. And we release all of that, and the ability for decision makers to quickly go in and get access to that kind of data, present it, make decisions based on it. So that's come up a couple of times in presentations. Like ultimately the point of this stuff is the human is looking at it and wants to do something actionable, make a decision, go somewhere, decide on some policy change, something. So having the ability to quickly iterate on that and productize things is really important. And then another thing that was brought up was siloing. So that definitely happens even within Geotab here. We've got a lot of different departments, some of which are newer, older. There's legacy systems. There's a lot of interoperability things. Over the last few years, we've migrated most of our services internally onto the Google Cloud platform. And actually like last year, BQGIS came out. So we use BigQuery as our data warehousing environment, and they added native geospatial support into BigQuery. So up until then, departments had different ways of kind of storing and managing their geospatial information, and we had different ways of trying to visualize that and play with it. But just the fact of just baking in that standard into the tool that everybody uses, now like by default, if your geospatial data is in BigQuery, I know it's in the right format because it's natively supported. And that made it a lot easier to just communicate and share data across the departments that we have here. So baking these standards in like immediately starts to break down these silos, at least in my experience.
Thank you.
Yeah, so one of the things that attracted me to Mapbox is the kind of humanitarian work folks have talked about here. The humanitarian OpenStreetMap team does amazing work activating in the wake of disasters, and we've been privileged to help to arrange donations of imagery from partners like Maxar, formerly Digital Globe. But in some ways that's an outlier. I think that there is a more predictable process by which data gets opened. When I was running the search team at Mapbox, our coin of the realm was address data points. That's what we really need to provide accurate geocodes for end users for a lot of important use cases. And of course, the first thing we do is go around to individual governments and see if they had them available on their open data portals. It was really interesting to learn sort of where the dividing line of density was. Highly populous and economically successful areas typically have these points available for download, or you get them easily enough. And then more remote places that were focused on extractive industries, oil and gas, timber, stuff like that, you'd have to send in a check and then they'd burn you a DVD-ROM or whatever. Or they just didn't have the data at all. And this makes sense if you think about it just in terms of infrastructure. If you are trying to build a road into a remote wilderness to service a property you bought, you're gonna have to pay somebody to do it. But it's a socialized cost downtown to maintain the roads, because it doesn't make sense to send everybody a bill individually except as part of their taxes. It's a piece of infrastructure everyone's going to use, and people bit by bit are understanding that the same holds true for geospatial data, which is great. It means that we can expect the open offerings around the world to keep getting better and better. And partly that's the work of governments, and partly it's the work of dedicated volunteers. I just dropped a link in chat to the OpenStreetMap statistics page. And you'll see there's millions of nodes getting added every single day to this project. Now there are other challenges to this. One's familiar to anybody who follows Wikipedia in terms of the culture ossifying and the welcomingness to new contributors. And there's also questions about new types of data. The classic use case of tracing roads and buildings from satellite imagery is something that anybody can do from their armchair from any point in the world. It's harder to map turn restrictions or other more subtle types of data that require additional data sets that aren't available in the open, or which are frankly just really tedious and require a lot of technical knowledge to do. I think there's also open questions about different types of mapping that are being done that rely on GPS sensor traces. And there is a capability to upload that to OSM, but the large scale collection of this stuff to do things like detect real-time traffic conditions, nobody's yet figured out how to do this safely in a totally open way, because there's really important privacy considerations and economies of scale that you have to cross that mean that commercial entities or governmental ones are really the ones that are in the best position to solve these problems. So there are some real challenges related to sort of the next frontier for spatial data. How are we going to get street level imagery on an open basis refreshed frequently enough to be relevant? How are we going to get a truly navigable, fully open road graph? But you know, in general, the trend toward openness has been great, and I think it's really superpowered a lot of the industry and the businesses of people on this call.
You Ed?
Yeah, again, it's hard to sort of disagree. Although I think, you know, there probably are, if we're honest, limits to openness. I think by all means, the sort of direction of travel is towards greater levels of openness because it reduces friction. It allows us to interoperate. It allows us to break those silos down. And when we choose to share data, it makes sharing more valuable. But I think we also have to recognize that there are business models around adding value to data sets, to creating processes, algorithms that use data to produce another product, another service, and we need to recognize that they will coexist. And the nice sort of I suppose example I use, I had a call earlier on today with some people in the UK who are building an open data portal for buses, national bus routes and so on. Well, not that many years ago, a few years ago, GTFS was created as a open standard for people that wanted to publish bus and public transit information. It's now used across the industry by many vendors. It's a mechanism by which, if you choose to make data available, it's a way that you can do that in a standardized fashion, and it allows an ecosystem to then develop around that, where app developers can build their apps that, if you're a passenger, you get information about how well your bus is running. If you're a provider of services to the bus operator, you can build them an app that consumes the data and adds their own management information as well. So it's those examples where you can identify, here's a case where everyone wants to get access to very similar data. Can we put in place a mechanism that meets the needs of 80% of that community and then allows those ecosystems to develop around it, and allows some companies, if they wish to be commercial and make money out of the process.
So touching on a few things that for this topic that sort of come across, sort of need for both internally and for exposing data to others, and the importance of standards is one thing I heard. I'm trying to settle on some core ontologies or data models. There's the government entities were mentioned. They are some of the richest producers of open data sets, for sure. There's also quite a bit of researchers that have taken tax dollars, public funds, but have otherwise sort of encumbered their results for various reasons. And as we sort of mentioned, there's, even though a lot of the commercial providers are exposing some of their data, there's some things that they're keeping close for themselves. But it seems like if there needs to be some way to have sort of open understanding of what data is available out there, even if it's under restricted terms. And it may be sort of multiple licensing capabilities for research purposes. If you are using this data set, what you have to do as far as giving backs for like a Apache software license kind of thing, or what have you, or for commercial interests, where you're doing a value add, you'd be making money off of this data, what you should be giving back, if you're getting a commercial data source. Are there sort of things along these lines that can maybe, help us to sort of figure out how to make people aware of what's available and trying to sort of normalize the concept of catalogs and exchanges? There are some various efforts. I know National Resource Council of Canada is doing a big project in that, where they're trying to build huge catalogs, data lakes as they're calling them, of sort of private and public sector data. And I'm not sure how much that is being used and mirrored and modeled for elsewhere, but if people have knowledge of things like that or ideas on what we can try to do better there in order to, people can find data proactively instead of, when there's a crisis or when there's a business need, or generate revenue streams, additional revenue streams for your companies, these sort of things.
I think I'm a bit of a radical in this position, in that I'm no great fan of data catalogs or the traditional approach that we've taken as a geospatial industry for separating out the content and the metadata. We've had metadata catalogs. We've gone down the route of creating quite sophisticated schemas for describing geospatial content, which you would go to a specialized server, come up with the query language to negotiate with that server, and you might identify that some data sets exist somewhere. But as a result of that, in many ways, artificial separation between content and the metadata about that content, it's been hard to access information that is useful and is actionable. Now, unfortunately, I think things are changing. You see things like the stack, and you see the direct publishing of raster data sets in a much more accessible form, where you actually are tying the metadata to the actual data itself, and with a traditional search paradigm to try and query across those data sets and to parse them in that way. It's making geospatial information more mainstream, more like any other data set that's published on the web. And indeed, we're beginning to have those initial forays into a linked data approach to geospatial information, coming up with better semantics to understand how we publish geospatial data. I think where we need to move forward, again, is, I guess, always my message, is we need to be more mainstream. We need to be much more standard citizens of the web, as opposed to creating our own separate geospatial web where we did things differently.
Yes. May I step in?
Yes, please.
I think the one thing is making the information available and kind of searchable. The other thing is to make it digestible and make it easy to evaluate this information for consumers, for users of the data. So you need to figure out, okay, is this data usable? Does it have a fitness for my use case? Is for example, the road network that is available by a governmental institution or by an Mapbox or by OpenStreetMap itself, by Google or whatever, who's the supplier, is this fitting to my use case? And having this in a kind of standardized way and making it easy for the consumer to evaluate the data. I think in many use cases, even consumers do not know about the requirements for their use case. And there is in many things not a standard way to evaluate the quality of spatial data.
Yeah, they definitely.
Yeah.
And just having.
Sorry, go ahead, Daniel.
Oh, sorry, Tom. And yeah, just having the data available is like just a very simple first step in that. I mean, like Statistics Canada and like other websites in the US and abroad have lots of data kind of in these data lakes that they've just sort of dumped there from historical uses because they've gotten the mandate to do that. But not all of it is high quality. Not all of it is useful. Most of it is not accessible with an API or any simple methods. So like I've got like a team of interns running around trying to scrape like open data from all these open data portals and then spend weeks getting it into our environment and then visualize it and then see half of it is useless. Like there's no easy way to get all of that or to understand its utility until like a lot of work has been put into it.
Yeah, I think this is one of the reasons why I get very excited about some of the ideas around distributed tiles that have been discussed in earlier presentations, but it's hard for me to see it working. What Johannes was gesturing toward, I think, problem we occasionally run into, right, where we can see a customer who maybe wants to render Mapbox tiles and route against here tiles, and that can lead to really weird behaviors. Even just using OSM by itself, you kind of need to know which version canonically you're pulling down. You've got to have workflows to watch for vandalism. you know, other ways of correcting bugs, since it is a widely used database. One other thing I'll say, and I'm sorry that I will always go back to address points as my example, but probably you should all just resign yourself to that for the next 30 minutes, is the Open Addresses Project. So there are a ton of governments that are publishing address point data. A lot of them have decided to invent their own data licenses, which is not super helpful, to be perfectly honest. Others are aiming for compatibility with OpenStreetMap's Open Database License, which is great because they are doing it so it can get into OSM. In practice, there are political, cultural, and legal obstacles to the simple import they're imagining, and ODBL is not really used by anybody else, has some known flaws, and has never been tested in court. So that situation is not great, and you wind up with then standards bodies writing these gigantic, hundreds of page-long XML documents about address specs that nobody uses. And instead, there are efforts like Open Addresses. Again, I'm biased here, but this is, you know, a few volunteers going out, finding the URLs of these data sets, writing simple little JSON snippets that say, okay, this is what they called the latitude column, this is what they call the longitude column, this is the projection it seems to be in, this is whether it requires attribution, whether it's share alike, or whether none of that's required. And you're still going to have to get your own lawyer to go through all this stuff. But the output of our system is a big CSV that you can import, and you don't have to do this for every county in the US or, you know, every department in France. And that's the reality of what you actually have to do to use this data. Putting it up onto a government website with a bunch of metadata is one thing, and you can pat yourself on the back for a job well done. But for any user whose use case extends beyond your borders, I think that more attention to operability would be really welcome and would deliver a lot of value to your citizens and users.
So the geospatial, or especially on the web, interest groups, when we rechartering, they're taking up overhauling the, especially on the web best practices document. And this, you know, it's maybe an opportunity to, without something that is not you know, a confusing standard that no one adopts and doesn't involve the various stakeholders and no one finds out about, and won't get there. You know, hopefully there's ways that we can try and improve awareness, improve, you know, create some baselines, maybe an opportunity. So that work is kicking off right now, so that's an opportunity. I'm focusing a lot on data, and sort of apologies, I guess, for that. This is Maps on the Web workshop. This is the content that's going in behind it, and you know, extremely sort of valuable, necessary. There is a wealth of information out there, but it's hearing and heard in the past how unusable it is in a lot of cases. You know, and agree, you know, to the extent that you can keep things simple. So because you have to keep in mind the multitude of audiences producing this information. If you can sort of boil it down to something, you know, kind of dread to even hear CSV in this day and age, but you know, it is a common denominator. It's something that people can produce and readily, and you don't have to someone engineer for a government entity who's, you know, told to open up this data in some format, and their eyes will get crossed trying to figure out how. If we can give them some basic guidance, some ways to do that, that would be a huge help, and then hopefully be able to increase it from there. We have a question from Karel about OGC user feedback. So the Spatial on the Web group is part of that. So I guess I preempted your question with the partial response, as far as, you know, what the OGC community itself is doing, but as far as the OGC W3C joint community, which is Spatial on the Web group. But are there other people, either panelists or in the audience, that can maybe speak a little bit to that, as far as what sort of feedback they're hearing on geospatial data in general and sort of openness?
Well, I mean, I can speak from an OGC point of view, being a director, or at least on the board of directors for OGC. There's a big, you know, it's a big change afoot at the OGC in the past, I'd say 2 years probably, where there is now a focus of becoming much more developer friendly in terms of building APIs that are, again, more standardized, using Swagger Open API as a design principle, and making sure that, you know, much more of the activity happens in the open. So you see much more work now happening in GitHub, and it's a largely, hopefully, a more open process. Yeah, there are still challenges there. OGC traditionally has been dominated by large government agencies. I think OGC as an organization needs to work hard to sort of broaden its appeal to that wider community of users of geospatial data as opposed to producers. And that's, I guess, where the balance needs to shift a bit. But I would hope that most of the people on this call see OGC now as a more open organization than it was perhaps in the past.
W3C went through a similar transition a while ago, and still, it's always a balancing act, and both organizations are similar in their revenue models, being membership based.
And I think there's also recognition that it's more than the technology. It's about bringing communities together. Tom made a really good point about openness and around the complexity of licenses. I think there's still a lot of work that we need to do to come up with a robust form of data licensing that parallels what we do with software development. We know what an Apache license is, we know what a GPL license is. We don't have the same level of granularity when it comes to how we process and how we publish data. So I think there's still more work to be done there.
Most likely the collection of Creative Commons licenses may be more applicable offhand, but I'm not a lawyer, thankfully. Anyone else have sort of thoughts on this particular question or topic at present?
Yeah, I think this is a super important point. So, and it's definitely comparable to the things that you do have in the software industry when you need to figure out when you're shipping a software to a customer, you need to have a license compliance. So in many software products, there's like 80% of the software is open source, and you have the whole bunch of software licenses, and the same would be the case for geographic data sets. And it would be even more complicated having a look at all the open database or open data license models that you have, at least here for Germany and for all over Europe. I think in Germany, every federal state has its own open data license for the data sets that are given by the governmental institutions, by each municipality and so on. That's a super mess of licenses and data. And if you want to make use of that and harmonize this data for an end-to-end routing, let's say across Europe or across all over the world, that is getting super complicated. And you need to have an homogeneous handling of these licenses, of the data formats and so on. And if you then implement on top as an in-between layer, for example, a routing engine or a search engine, you need to digest this data. You need to take care on the different license model. And this is, at the end, this is the business that here is doing now for roughly 35 years by providing this for automotives in such a case.
Thank you. Chris Little provided another answer to Carol's question, saying that maybe she's talking about the OGC standard for user feedback, and provided the link, which will be, we'll make sure it's part of the minutes proceedings, and it's currently in Zoom chat. Thank you, Chris. So look at the clock, and we have still plenty of time, but try and get back to GIS data is going to drive maps on the web, is providing a lot of content. And but what are some business use cases that pertain to your companies as far as what you'd like to see this effort, this mapping community address, that will help you become stakeholders in this activity, help you help drive and shape it, help what sort of considerations would you like to try and get them to think of up front? What are some of the cost benefits for you, instead of having to, if you can use the web browser as your interface to your end customers, does that reduce your costs? If you're leveraging more of the web stack instead of doing proprietary interfaces, for example. What sort of, we've had quite a bit of presentations and panels on accessibility enhancements, which is extremely important part of Maps on the Web. How do you currently make your mapping solutions accessible, or try to see that the importance of open standards for a harmonized approach for helping increase the accessibility of mapping on the web. So what are some business cases or things that you think may influence this this effort, this activity, in ways that you can maybe bring it back within your companies and help make the argument for why they should be involved, kind of thing?
Well, for us, unlocking performance is really important. There's always more that we would like to do to enable more flexibility on the client side, and we're really bounded by what's possible. And this gets down into the nitty-gritty of browser implementations. This is less standards work than just getting the implementations right. This was alluded to in Andreas's presentation on open layers and some of the constraints they're facing using off-screen canvases. I've run into varying differences in how the performance resource timing API is implemented in web workers across browsers, which interfered with some of our benchmarking. That's pretty deep. I would say it's hard to find very many tickets about this stuff being broken, but that's really important. Moving to a native implementation could really unlock some additional performance, but it's going to have to be at the leading edge, and in turn, that performance is going to open up new capabilities for doing stuff on the client. Like I think I spoke too dismissively of the idea of throwing GeoJSON at on top of a map. That is like an incredibly flexible and powerful use case. And if your data is small enough to do it that way, you can do more with the data in that form than basically anything else. The problem is that it's not performant when you start adding too much. And so you have to do pre-processing into tiles or other optimizations. You have to, rather than relying on the lovely vector drawing APIs that exist in the browser, you have to draw each line as triangles with WebGL right now. Anything that can be done to unlock more performance will push the frontier forward. And if standardization can be part of that, then that's really great.
Anyone else want to speak on that one?
Yeah, I mean, I agree with that 100%. Like a lot of this stuff there, go really close to my microphone for everybody in the chat because I keep getting complaints. Yeah, a lot of the stuff that we're doing now, we're coming up with workarounds around performance constraints. Like, so there's stuff that we could be doing. Like, we have petabytes of movement data from vehicles. Like, there's a ton of stuff we are doing and could do with that, but there's only so much stuff that we can put on a map with GeoJSON rendering on top of raster tiles, right? As soon as we get to like a couple million points using like current implementations, it just grinds to a halt, especially because most of the rendering is happening on the user side. And there's only so much their computers can do, especially when we're working with public sector community. So that's really a limiting factor. And then, I mean, you mentioned the accessibility. So I actually just had a call this morning where we've got a mandate internally and make sure every single one of our products is aligned with AODA, which is the Ontario, where I live, province for disability stuff. There's the ADA stuff, et cetera. Kind of how do we do that with all of the novel like mapping representations that we're coming up with smart cities is not an easy thing, and it's not something that's really standardized right now. So that's going to be a challenge for us for sure. And then the other thing is just kind of coming back to interoperability. We're working with a lot of cities. They've got different data, different legacy systems, different ways that they want to look at things. And if I've generated data sets, for example, with OpenStreetMap, and they want to see it kind of projected onto Google Maps, and somebody else wants it routed with here or something, there's like a lot of different interoperability considerations, even in just visualizing this, that I currently struggle with.
I look at it from a slightly different perspective. I look at a web page as a source of data, and let's take for example, a location of a business or a hotel or a shopping center. You'd see a web page of which there may be a map presented on it, but almost certainly there'll be textual description of the address, maybe the opening hours. What I'd be keen of is better semantic tagging of that content on the page, so that a screen reader can read the address, but then have the semantic understanding that in this case, this particular store is in Ottawa, which is in Ontario, which is in Canada, and you could have a dialogue with an intelligent assistant that understood that content as geospatial information, understood the geospatial relationships that were presented there, and could almost do that without reference to the map, because the map by its very nature is a very visual representation. If we can have that same content expressed in other ways, and the geospatial ideas behind that information also presented, I think that's going to give us many other opportunities in the future, not just from an accessibility point of view, but from the machine-to-machine processing of this data moving forward.
Johannes, do you want to add anything on this one, or no pressure, no obligation?
Yeah, it's yeah, fully true. I agree with that. Yeah.
Okay.
I think maybe one point. So as we talked a little bit about business models or what could accelerate this behavior, and I also just saw Jonathan who put some data into the chat of his massive database about licenses and license models which are available of this somehow open accessible data sets mainly via OGC interfaces, but also via SRI proprietary interfaces. And I think this is definitely something where we need some work on to clarify how this data can be used. We do have on consumer side safety on use this data and building business models maybe out of that, and having as a consumer and the producer the opportunity to to make money out of data and building businesses on top of that. If the provider of the data is not able to provide an exact license of the product, which is being open for public, then it's very unsecure to build a business case on top of that, because you don't know how the decision would be. And this is a layer which is needed to bring some safety into the market. And this will also start thinking about the quality of data and figuring out what kind of attributes and variables are needed to specify, to describe the data, which would go probably beyond the metadata description which is currently available.
Sorry, I'm using my iPad for Zoom, and I'm getting way too many dings. Apologies for that. I hope they're not coming through. They probably are. So a big revenue and regulations are two of the biggest motivations for commercial interest. Daniel mentioned ADA and the Canadian equivalent. And of course, these similar things exist in the EU and other parts of the world. And it's just to sort of drive home a point that I feel about, and clearly a lot of our participants do, as part of this workshop, is just sort of a reminder, not just to, not directed to the panelists, but to all attendees, that sort of it's not just protecting yourself from lawsuits for creating products that are not accessible as required by law. It's also keeping in mind a good portion of your audience, your customer base. I had stats from a previous conversation I did with someone from the Web Accessibility Initiative about how pronounced portion of the population has varying accessibility needs. So you're just a reminder that you're sort of cutting out a big piece of your customer demographic if you're not doing this at the outset, if you're not thinking about it. Response to the licensing as far as business use cases. So we're talking, this sort of combines the earlier topic as far as data and trying to be able to license it. People using an open web stack and making it so that maps for the web are first-class citizen, and then you can sort of tailor your products to be cheaper, lighter, and available on more platforms more readily. without having to sort of port your custom interface, because you know there'll be a browser runtime there. But it's also allowing opportunities to license not just the data, but some various services on top of it that does the value add to other people who will be able to take your products to a next step further, or to specific target audiences, not just accessible, not just for accessibility needs. What are some current technical challenges that you see that it kind of blurs with the business use cases a bit, but any sort of technology challenges that you like to, we've actually heard several throughout this, so I guess it's sort of an opportunity to express any additional ones that you'd like to try and get out there and get in people's ears and minds as they're working on maps of the web. What are some things that you like to, some challenges you face that you feel that this community will as well, as they try to make maps more prominent on the web as part of the
Let me jump in, Ted, because you mentioned accessibility, and I just want to briefly say this is one of the reasons why I think it's really important for people to engage with vector tiles as a technology, because they carry semantic content, not just rendered visual content the way that raster tiles do. They can be inspected on the client side, and you can do all kinds of things that make the map experience dramatically more accessible. Just a couple of weeks ago, I saw somebody's dissertation across my inbox, an iOS app with extremely high contrast mode and tactile feedback. You know, make the map vibrate when your finger crosses a road line for people with visual impairments. And that's possible, you know, using the exact same vector tiles you might use to power a conventional display. So that's one of the things that makes that technology really exciting. Still faces constraints though. This is one of those things that I you know, for all the hype, I do think that we're going to see some exciting things with 5G and other technologies deployed, because you know, right now our rule of thumb that we enforce is 500 kilobytes per tile. That limits how many languages we can support for labels. It limits the precision of geometry. It limits how many features we can include at a given zoom level. We are optimizing around this to try and balance the incredible power you can pack into one of these things using Google's protobuf technology for the sufficient binary representation with a good experience over mobile networks. And you know, that's gonna keep getting better. I don't know that it's I don't know everybody who's on the Zoom and if any of them are responsible for the state of our wireless networks, but if you are, keep up the good work. I think we're going to get better maps thanks to your efforts.
Any other thoughts from others?
I guess my wish list, if there is such a thing, is a better positioning technology. We produce quite good solutions now that work outside with a clear view of the sky, but we spend, indeed at the moment, we spend an awful lot of time indoors where most of that technology stops working as well, and we can't really deal very well with the transition between indoors and outdoors. And particularly again from that accessibility point of view, if you're dealing with people with you know, limited vision, having accurate you know, turn-by-turn directions delivered by voice both outside and inside require us to be able to position ourselves down to less than a meter all of the time, and there is no real technological solution for doing that at scale at this point in time. There's work in progress. I think in the next 5 years we will come up with those solutions, but if we can solve that problem now, that opens up a huge range of new applications that regard the indoors as a geospatial realm, just as the same way that we regard the outside as a geospatial realm. I think it's a change of scale that we're operating at, but I think that's going to be a really exciting near-term future.
So I haven't been there in a while. I work at the Status Center at MIT. Actually, we got bumped to another building, but it's a Frank Gehry building. There's not a lot of straight lines in that place, and they've tried with various NFC and other things to try and help people navigate. There's per accessibility laws, there's Braille all over the place as well, but indoors is normally a challenge, and there's ways that make it even more so. There's a couple of community groups at W3C. We heard from the linked data for accessibility folks before. There's also a linked building data group that's looking to they're actually more focused on building capabilities and what it sort of has to offer than the internal navigation. But the linked data for accessibility folks are trying to include data as far as how to move within a building, what its capabilities are and offerings, things like that. So we only have a few minutes left. Give the audience some opportunity to throw in some more questions before we sort of wrap up. But in the meantime, like, what are some new opportunities, some offerings that you see that improved maps on the web can bring? We've heard some of these sort of come up sort of already, but that was sort of the last of my topics on the list. So any sort of, what do you see this this activity possibly opening up as far as smart cities, more sort of interoperability, multimodal transportation coordination for when we can travel again, various things like that. You know, anything sort of come to mind that sort of you think might be sort of among the various killer apps that will help sort of drive this space or I shouldn't use killer apps, but what are some of the big sort of bigger picture initiatives that can really sort of benefit from this that might come to mind, kind of thing? No one, sorry.
I guess I would take it from the other side, right? Is that I think that there are simple use cases that should be simpler, and you don't necessarily have to bite off augmented reality or you know, some of the stuff that's at the bleeding edge, right? Like there are a lot of people who want to do some simple thematic mapping or heat maps or you know, or chloropleths, like things that it would be really nice if you don't have to understand the difference between like the natural Earth data sets and you know, what open layers versus leaflet is to get up and running in your web browser. Stuff that, you know, spammy W3 schools links should cover. I think it would be great if we could clear that bar and make the basic and generally openly licensed ADM0 and ADM1 geometry ship with browsers, and ideally have like Wikidata links so that people can tie into a semantic universe of associated data, and just make like the simple stuff simple. That would be really cool.
A quick clarification: W3 schools is not related to W3C. We never sent a cease and desist way back in the 90s when they started. But anyway, Daniel, looks like you wanted. They do good stuff. They do some good stuff though, nonetheless.
Yeah,
I agree with Tom. I think just get the simple things right. What appealed to me about this whole Maps for HTML program and the work that Peter's been doing is actually making it even simpler than it is now. You could argue, well, you know, over the past 10 or 15 years, we've made maps on the web much simpler than they once were, you know, but actually there's still a long way to go to make it, you know, as simple as possible. And for, most importantly, for, you know, anyone creating a website, a web application, doing anything in the browser, to actually understand, oh, okay, that's a piece of geospatial content. I know what that does. I know how I can interact with that without, you know, necessarily building the huge JavaScript libraries that we have at the moment. If there is a core amount of functionality to allow someone to put a map on a web page, to have basic interactivity, to put a pin on that map that makes geospatial more mainstream, that's what we should be aiming at.
Thank you. So Daniel, Johannes, should have actually said during that question, should have gone with closing remarks kind of thing, since we're coming up to the top of the hour rather rapidly. But give you guys also a brief opportunity to put something out there, and as a reminder to everyone, discourse links will exist on the agenda page and in the minutes and various other things as far as continuing the conversation well after this workshop. But Daniel, Johannes, any sort of either sort of closing remarks, or in some ways what the future would hold, and what are some including opportunities was sort of meant to be kind of that topic as well. So
yeah, just briefly, I guess I'll just pile onto that, and then that kind of feeds into your question. Like making things simpler going forward. It's like our business model is primarily through resellers. Like we realized early on, we can't be all things to all people. Maps are really complicated, and our end users can't really handle a lot of that on their own. Our value, like I think, is in the data and the algorithms that we apply on top of that. We're not map makers. We leverage maps to display that information to our customers, and we have a whole team of people building interfaces for them to do that. But if there are simpler ways for our resellers to just ingest the data that we're generating for them and customize it to each of their own customers, then we can be a lot more hands-off on that. And as like these kind of standards develop to make that easier going forward, we can redouble our efforts on what our core business model is and where our expertise is, and less on building up these custom interfaces for our end users.
thanks, Johannes.
Right. So yeah, briefly, my conclusion for the future would be making the interfaces and the interaction possibilities for end user customers is a key thing that you're setting the right leverage to make it easy for users that are not in the GI science or the geospatial community to step into that and make use of this data. Just make it easy, and then let them explore the world, because it's getting more complicated. You see how drones are working with data, the IMU stuff, the whole geodesy stuff, which is super important for having high precise navigation and having an understanding of the quality of the data and how useful it is for my use case. What do I need? How should I evaluate the data for my special use case? And the easy access to the, let's say, the first level, this will open the door for the broad universe of geospatial content and spatiotemporal content at the end.
Thank you. Tom, Ed, any brief last parting words of wisdom beyond, because like you were answering the question and it sort of was along those lines as far as last steps, and you kind of gave that, like, you know, keep it simple, solve the simple for now, but if there's any other parting things before we wrap up.
Just adding anything would complicate things. Just keep it simple.
Keep it simple is a good thing. Tom?
Yeah, I'm afraid my coffee's made me talk more than I should have. But yeah, I think keeping it simple is a good place to start, and I'd really encourage everyone to try and engage with I think the open mapping community has not done as good of a job as it could have making clear how its stuff works to other web communities, with important exceptions. I mean, I was delighted to see Iván here, to see Andreas here. I know that there's important amounts of overlap, but there's also like a lot of work that this effort could be taking advantage of that's out there. And yeah, I'm excited to see where the proposal goes.
Thank you all for the panel, for your participation. Apologies when I stopped looking at the clock because it was, you know, worried that we're going to run out of time. We've gone too far by a couple minutes. Peter, do you want to hand back over to you and see if there's any reminders you want to make before we wrap up?
No, but I just want to thank the panel for being such good sports and participating today. It's great to engage the community and different mapping providers and so on. As Tom was mentioning there, we've tried our best to keep it out in the open. I mean, we don't have a big publicity machine, but it's a community group, and we are welcoming of all contributions, large and small. So yeah, how to keep it simple is not as simple as one might imagine. So definitely welcome contributions in that regard. Okay. And with that, I guess we should move on to the next part of our program today, which is a breakout session that's going to be led by Karel Charvat again about their whiteboard application technology for collaborative map making. Over to you, Karel.
Okay, thank you. Runar, I would like to ask you if you can share the presentation, and I would like to start that I'm happy what I heard on the conclusion. Make the things simple. Yes, I think that this is something what we see as very important. We will try to explain how we are trying to do the things simple. Maybe that we can discuss how to do a little more simple in the future. I would like to ask Runar if you can start with some introduction.
I will. Can you see my screen is what I'm first would ask.
Yes.
Probably. Okay, so you can see something saying collaborative map making. Okay, good. So I'm going to try and make some sort of introduction to this. In Europe, of course, it is evening. I don't know how it is for how our audience distributes among different places, but I expect that during the next half an hour to hour, we're going to discuss a couple of ideas that we've had that we will believe it's probably a layer above in complexity of what we've been discussing so far, where we've been sort of discussing the base enabling technologies, the wiring that is required to efficiently and interoperably deploy base maps. We are sort of one step less sophisticated, perhaps, and higher up in the value chain, depending on how you draw the diagram between the technology and the end user. But okay, we are going to divide the time a little bit between three different speakers. It's Raitis Parsons from Baltic Open Solutions in Latvia, Karel Charvat, who is some sort of copy of all technology companies in the Czech Republic, and myself, Runar Bergheim. I'm from a company in Norway that didn't think that it would ever operate outside of Norway when it chose its name. So it's called Asplan, which makes many people believe that we are some sort of assembly of proctologists, which is not a good thing. We all belong to some sort of a siblinghood that goes by the name of the Plan for All Association, which is a spin-off from an EU project back in the day. So far back in the day that it was back when people still shook hands and said hello to each other. And finally, it's also the intention that this should be an interactive session, and most interactive sessions never turn out to be so, but we have nevertheless a discussion section on this where people should feel free to attack and or voice their support to whatever we say. So I'm going to first try to put this into a little bit of context, and then we're going to demonstrate these two concepts. So the first thing is that we were sort of encouraged by the first presentation here today when we heard this wonderful sentence, I believe this is useful for something, but I don't know exactly what, because this is sort of the universe we come from. But when we have had a relatively small idea of something that we think could be new and valuable. And we worked on this idea not because it was scientifically smart or because the world sort of was screaming for it and this was a need that would sort of radically change everything in the universe. But once we are presenting this to the OGC, which is sort of a behemoth of organizations on map standardization and contribution to the common good, we felt the need to sort of wrap what we are saying in a quasi-scientific innovation. So, like so many before us, we are going to try and retroactively fit a scientific rationale to our little idea. And had it not been for the fact that I'm telling you this, might have led us to come out in a more favorable light when you assess us. We are talking about collaboration, collaborative map creation. And we have become very good at collaboration, I think. I think it's fair to say over the past 20 years, we have become very, very good at this with a process that has involved many of you at various stages. And I mean, you have made, some of you who are global players have made decisions and choices in your organizations that from your perspective have been business decisions, but that have propagated to a massive amount of value creation in small communities around Europe that you would never imagine that even existed, like my background here, for example. But there are a few things that are still remaining. I mean, the first barrier that was torn down was map data licensing. access to high quality maps used to be one prime barrier of mapping. And we had all these sort of mapping agencies that came out of the military tradition that thought that if people would gain access to data on public roads, it would immediately lead to the full collapse of national security. But then, of course, Google, our friends, started to publish global base maps that were better, more concurrent, and suddenly there was no sort of good political rationale for saying that we can't give you our data anymore. The second catalyst, I think, that has been very, very successful was the web map service, but it doesn't, of course, give you access to the data, and that limits a little bit the usefulness when it comes to many business cases, although it does greatly facilitate the base map delivery aspect. But strangely, as was mentioned there before, I mean that there are still a couple of file formats and sharing modes that are still common staple in 2020, despite being equally common in 1985. Well, maybe not 85, but 95 at least. The shapefile has a very long life. It's very difficult to kill it. And I would say that in this era of public sector information portals, the .gov portals, the CSV files, although technologically not particularly interesting, have been the big winner. This is the format that carries the most public sector information, and also a surprising amount of the geospatial information is point data comes in this guise. We become quite good at sharing map applications, and these applications come out of two camps as I see them now. There are those that lend heavily from the professional GIS software and try to replicate somehow on the web what ArcGIS used to be in the 1990s. And there are those that come out of the Slippy Map APIs, like leaflet open layers type of maps that take a performance approach to creating a good map experience on the web that is not necessarily designed for people who have been working with GIS since the 80s. However, these map applications, they give you this challenge that they often give you a tool. They give you a blank map, which doesn't necessarily look unpleasing. And it's very good if you know what you want and if you know what you can expect to find there, but it often challenges you to make this map yourself. And this old-time map that tells a story is nowhere to be found anymore. So we are not so adept at sharing maps as we are at sharing data and applications. We become quite good at creating data. Our satellite missions, of course, nowadays provide so much data that we couldn't possibly do anything about it, whether we tried. And while Landsat, of course, is a forerunner, I'm European, so I need to show Sentinel. But we have become quite good at this. We become quite good at creating data together too. I mean, the OpenStreetMap is a ubiquitous base map, and I think particularly the efforts of the humanitarian OpenStreetMap team shows that this methodology scales. I mean, the non-centralized ad hoc data capturing to support humanitarian needs on demand. This is something that works very well. This is progress. These are problems that have been solved. But once we have solved the big problems, new ones appear, and they are perhaps smaller, less significant, petty problems, one might say. But user-generated content as it is today is very much a dialogue between the user and the application he works with. And this, of course, presumes that the user who creates data is also the user who knows both technology, GIS, and has the knowledge about the local terrain where he works. And we believe there is some room to enhance this process, as we will try to go on to demonstrate. Then, looking at creation of maps together, we have become good at creating data together. I don't think we have become good at creating maps together. We don't do it. And I would say that the state of cartography in the world has shown a unanimously negative development, where early maps used to be you know, works of art with borders showing fanciful pictures of the waterfall at the edge of the world, and here be dragons, and you know, things that were distinctly pleasing to look at. Today's cartography is very much more of the nature on the left. They may be more useful, they may be put to better use, they may be part of common operating pictures in operation centers, but they are not beautiful. And we think there could be a use case for collaborative map making too. And the reason for this is that there is 5 things that haven't changed as much as we could have hoped for during the last 40 years. One of them is that somewhere in some deep, dark recess of most government GIS departments in 2020, there is still some sort of a large format plotter looming. There is still a significant chunk of middle-aged gray humans who are huddled around poorly ventilated meeting room tables, peering over some sort of a printout of a map, pointing and gesticulating and spilling coffee and cookie crumbs and whatever it is that they do in this process. They're invariably annotating these maps by markers, and they're pointing their fingers a lot to explain what they mean. And finally, this is handed over to a GIS specialist who then has the very hapless and tragic fate of trying to distinguish what is a chocolate chip smudge and what is a new development area that should be adjusted in this map. And thus, maps are still edited collaboratively in 2020. So we think there is room for some improvement there. And if 2020 has taught us anything, except that when it rains, it really, really pours, it is that a lot of physical meetings are, and hopefully shall remain non-essential. And even those of us who are most opposed to progress have been forced to find some sort of way to live with online cooperation in this year. And so we think that some sort of evolution of sharing technology could be apt at this moment in time. And we're looking at some sort of a client-to-client map data creation that allows for a better experience in this way and possibly better quality. So I think this is the question that would form yourself in your minds as you hear me drone on about this. There is a distinctive first world flavor to the type of problems that I have listed here. This is not something that is going to solve world hunger or anything like that, but it rings a little bit of this first presentation of what we think this could be useful. We don't know exactly how, but we think it could be useful. So we'll leave you to judge whether that is so or not, and we will move on to introduce the 2 different concepts. The 2 are an interoperable way of describing, storing, and exchanging a map. And in this context, we're not talking about the map tiles or the rendering of it as such, but what could you say, a portable equivalent of the project files from QGIS and ArcGIS and whatnot. Something that would draw heavily on the OVS context or the web map context standards that were created far back, but that doesn't gain a lot of enthusiasm these days, although they are in use. And the second part is a some technology platform to enable client-to-client interactions for common GIS tasks. And for these 2 things, we have given some names: map compositions and map whiteboards. So the first thing we're going to talk about is the map composition, and that I'm going to hand over to Raitis. I will still operate the computer, I think, so I will be clicking the forward key, but I think Raitis will speak of it. So you just tell me when you want the next slide.
Okay, thank you, Runar. You hear me, yes?
I can hear you.
Yeah. So, yeah, I'm Raitis. I'm representing Baltic Open Solutions Center, and I will tell you a little bit more about the compositions. So, next slide, please.
Yes.
Well, as Runar mentioned, map compositions can be looked upon as a project files, and they are kind of a canvas on which we can draw the features or add some new elements. And they have been developed gradually together with the open source components, which are listed at the bottom of the slide, namely Aegis Layers, which is a UI extension of Open Layers, and it's a metadata catalog, and Layman for uploading shapefiles and converting them to WMS services. But actually, the origins of the map composition were very humble. We just needed a way to store the context of the current web map between reloads of the page. So later on, first we had some layers, and then we added the possibility for the users to draw some new features on the layers, and later on to add new layers to the map. But when the page was reloaded, everything was erased and the user had to start from scratch, so we needed to save it somehow. And from this capability we had developed it, we created a way to share this context. So we just had to have one parameter in the URL of the of this map application, and the user of the GeoPortal was able to share this context between other users. And this composition could be exported to the metadata catalog named Mitska, which also had a list of different WMS services or some raster images and so on. And these kind of data layers could be then mixed in various configurations and shared. Please, next slide.
Yes.
So the map composition format is very much based on the old OGC web map context, and its later successor OWS context. But what we have done is to encode the data into JSON format, so it's easier to parse in the web applications which we have been developing in JavaScript. So it's easier implementation. Next, please. And here is an example of a map composition. And on the right side, you can see the structure of it. It very much resembles the OWS context, but in a more simplified form. So what you have here is some basic attributes describing the context of the whole map or the container, like description and current extent of the map, and current selected base layer, because there can be only one of them, and map projection based upon which the application can decide whether to reproject the layers or not. And also some information about the permissions. So the application then can decide whether to give write permission to the users. We try to mimic the Linux file system using this. And then the main or the most important part of the map composition is the list of layers, where the order of layers matters. So the first layer in the array is considered to be the bottom one, and Yeah, so then continues the actual list of layer definitions, and it consists of basically two parts. The parameters which are sent to the server requests, either that is WMS or WFS, or different kind of web service, and also the parameters which are used by the client-side application. Currently, we have implemented the map compositions on top of open layers, and also some experimentation was done on leaflet. So these kind of client-side parameters could be single tile attribute, which tells the application whether to request the tile as one tile for the whole whole map window, or it will be separated into different smaller tiles. And of course, the visibility of the layer, or transparency or opacity, and so on. And for WMS layers, we can request the legend graphics from the web service itself, but for some static layers, static images, we have to also provide an array of legends. And same for dimensions. So at the bottom of the slide, you can see the URL of the schema of the map composition, but that is basically only meant for validating the composition against a schema which could be used on Aegis layers map library. So if some other GeoPortal solution would use this composition format, then of course it could have a different schema, because it would support different kind of layers and different parameters for them. Next slide, please. The main attribute which is present for all the layers, apart from the URL, of course, is the class or type name of the layer. We currently support WMS, WFS, and vector layers. And with vector layers, it's interesting that the end result is a vector layer, but the data can come from different sources. For example, it can be GeoJSON file, or it can be a WFS request, or it can be also added from Sparkle endpoint or KML. And we also support XYZ layers for OpenStreetMap, Bing Maps, and Google Maps. And ArcGIS REST layers are also supported. The last three types of layers are derived from the layer definitions of open layers. Next, please. Vector layers are subdivided by protocol property, but we could support, for example, Sparkle endpoints. And what we try to do in this example, this image, was try to load the data from Sparkle endpoint. It's a 5-star open linked data format or endpoint from Virtuoso, where the data comes described, where the data is described in the where the metadata is contained in the data which comes from the Sparkle endpoint itself. So it's not separated, but everything in one package, and it's easy for the developers to then go deeper to explore the semantics of the data. And yeah, it was also, this topic was touched in the panel discussions before. But for vector layers, we support this simple type of data as JSON format. And yeah, one counterintuitive but quite useful capability is to store GeoJSON encoded features directly into the composition, as opposed to having a link to some external file or service. This was intended for temporary low-volume data, such as scratch layers, or some layers where the user can freely draw some features, or take notes, for example. But we discovered that it's quite useful in the Map Whiteboard application, which we are developing. And when this scratch layer is being populated by the user, at some point the features could be stored or sent to some WFS service, or the layman application, which I was mentioning before, which converts data, either it is shapefile or GeoJSON vector data, into WFS services, and it serves them with GeoServer. So yeah, so at the end, the features can be merged from the whiteboard server into this map composition, and then requested by the user using just one request, for example, where the application just gives the ID of the composition, and then in return gets back the whole composition description with the metadata, the layer definitions. They can be vectors, vector features, or they can be pointers to WMS or WFS services, and also the features which have been drawn using the Map Whiteboard. Yeah, that's all from me. And
right, it's maybe that you didn't mention one thing, that through Mitska and Lyman, this composition can be shared also with QGIS as desktop solution, and also from QGIS you are able to publish such map composition which into catalog, which could be also shared with web environment.
Yes, that's some kind of late development, recent development. We have been developing a QGIS plugin for creating these vector layers, and complete map compositions actually can be created in QGIS and then exported to Layman and converted into lists of layers, WMS layers, very easily, and published. But it's still under development, so, but going well. If anybody is interested, it's available on GitHub if you search Layman, or Aegis layers for that matter.
Okay, so then we might move on to say something about this Map Whiteboard, which we've been referring to a lot now, but which we haven't actually told you what it is. I have the very unfortunate situation of having developed a cough, which is not a good thing nowadays. And if nothing else, you stand at risk to be rolled in tar and feathered by your neighbors. But I hope you will bear with me. I can also see from the camera here that I have turned purple, but I think that's more a question of lightning than really a general health condition. So hopefully you shouldn't be too worried by the fact that I'm coughing along the way. The Map Whiteboard as such is not a patented term, and if it is, it's not patented by us. It doesn't mean anything except whatever you put into the your own associations. However, for the purpose of tonight, it is, or today, I should say, to be slightly more globally inclusive. It may be considered to be a peer-to-peer technology that allows map interactions and modifications to a map to be propagated from one connected web client to all other connected web clients while they're looking at the same map. So when someone moves their cursor, I can see it on my screen. When someone draws a feature, I can see it on my screen. I can edit the features they've drawn. They can edit mine. We can add layers to maps, and they will show up with all of us, and so on. So I had uploaded here a, why did we want such a thing? The first thing is that in the early days, when we saw sort of the business cases for GIS with moving things on screen, we were very enticed by this idea of seeing things moving rather than just a static map. So we saw that from this fleet monitoring thing. We had GPS transponders on trucks and taxis that allowed you to see where things were. And this is very, very pleasing. Purely from a technical point of view, very pleasing. We don't own these taxis, we don't own these companies. There was nothing in it for us, but it was pleasing. So more relevant to our own lives, of course, we've been using Google Docs a lot for collaborative development of documents. And that is a very closely related discipline when it comes to certain things. We've been writing documents, and we had the pleasure of seeing, working multiple parties on the same things without causing any sort of conflicts among our texts. And we would like to see the same thing in maps. We've also been working a lot on user-generated content, and we have been bothered by the fact that it's always one person or two people sitting physically together in the same room working towards one client application, whereas this possibility of cooperating would require some sort of screen sharing, online conferencing tool. So we like and it would still allow only one person at a time to work in the map. So we thought we would like to see something like that. And then, of course, we have this irrational desire to see things move on the screen. And I had tried to make a small video of this, and I saw that that one wouldn't play. So I will try to play it. I will try to change to a different window and play it there. This is no bells and whistles, nothing particularly exciting, but just for the purpose of illustrating the concept, we made two full screen map surfaces. These are rendered in open layers. We have made the same client for leaflet because it's not necessarily meant so that this needs to work in one technology or another. It should work on any platform. But I'm going to start playing it now and see if you are able to see anything. So the first thing is that when I move my cursor in one map, the people connected to the map can see where I am, and each cursor is assigned a unique color. I will ask this question: can you see my screen still? Can you see a video playing on my screen?
Yes.
Okay, yeah, very good. Because otherwise this will be just additional fog. Okay, so every cursor is assigned a different color. And when I move in my connected client, my counterpart can see my cursor with a specific color. So that essentially takes out the business case of pointing with your fingers when you're standing around this around this paper map on the table. So then the second thing is that I can create data, and immediately when I create this data, they show up at all connected clients. And I can create all simple features according to simple feature specifications, and using all. I mean, this just depends on the implementation. The transfer of data is using GeoJSON. It might be that we should go to some more compressed thing because the volume here could easily drive up traffic. But you're able to create geometries of any kind. And we are able to see that they show up. And when I have created a geometry, a person can go to that geometry and modify it in the other window. So we have read-write access to all features that we have created collaboratively. And the same mechanism applies for property editing, so attribute editing, and also for adding another layer to the, I don't know what's happened there, also for adding another layer to the map. So if we are sitting in this sort of a map user context in a government department, and we are assessing some map, we can say that, okay, we need some supporting information. I can add a WMS service from my side, or a shapefile or whatever, and it will immediately be visible to all other users as contextual information that can be turned on and off in their map. And simultaneously, then we can see as the data goes. So we are able to both author the maps themselves and the cartography, as well as the data content of the maps. And that satisfies a number of business cases that many of our customers are suffering from, and that is a bigger problem for them in the era of COVID-19 than it was before, when they at least had the opportunity to meet in this very small meeting rooms of theirs. The technical architecture of this is based on HTML5 clients. Could be of course desktop clients, QGIS, ArcGIS, and whatever. I mean, in any sort of connected client, or it could be rendered on MapML for that in the future. These could be implemented using any library. We have so far just implemented this for OpenLayers and Leaflet, and some branches, I should say, some branches of OpenLayers, in addition to standard OpenLayers. Then initially we thought of just having this as a standalone editing technology that only allowed you to edit vector geometries in a random GeoJSON layer. But then we had in parallel this map compositions format, which has great overlaps with OWS context and so on, which might be questionable. But we had that one in our stack because we, as Reitis described, we needed it for some projects. So we thought, okay, maybe it would be neat to be able to edit both the vector layers themselves and to edit the map. So we chose to use the map composition as the carrier. And in terms of lightness of load, because here there's a lot of messages going back and forth between the client and the server, and then being distributed again, we chose GeoJSON because it's fairly light, fairly light way of encoding data. So the server part of this has a documented API. It's written in Node.js and Socket.io, and it would typically be hosted behind some reverse proxy when it's in a production environment. And immediately when my cursor moves, of course, there goes a message to the whiteboard server that user so-and-so connected to map so-and-so has moved. This message is immediately propagated to every connected client, and the state is synchronized on each client independently. But of course, if a client falls out and reconnects, it's necessary also to synchronize this on the server. So we have state management in MongoDB that sits behind this. So whenever we make any sort of map update, this is immediately flushed to MongoDB. So there is a completely updated version of the GeoJSON and of the map composition sitting on the server at any time. So if you connect or disconnect and come back, nothing is lost. It remains. There is, of course, a few issues here also, because if you want to have, I mean, this is a far less demanding technology that is, what could you say, it's not basic infrastructure like what the early presentations here described. This is sort of an edge feature in an application. But still, it has some performance issues, because if you would like to have smooth cursor movement and very responsive interfaces, you would need to transfer data on cursor positions in roughly every 20 milliseconds or something like this. And that leads, of course, to a lot of data being sent back and forth. So even GeoJSON might be too bulky for this. So you might use something like a protobuf or something like this to speed up or minimize the data that are being transferred. This is a very simple thing, but surprisingly, of course, an API that should be able to handle this on the server side needs to include quite a lot of stuff. We have to have user management. I shouldn't mess up your map, you shouldn't mess up mine. So even though we allow people to collaborate, we need to have the same permission model as exists in Google Docs, where people can have read access or editor access or comment access, suggest access, and so on. We need to have document management. We need to be able to upload and download these things and control who can do it. And we need methods to handle streaming of all these interactions from the server to the connected clients. And the server doesn't really care very much about the rendering of this. It cares just about propagating messages. But it needs to have some basic rules. So features and properties are represented as GeoJSON. Features are stored in layers. Layers are stored in map compositions, and map composition are rendered as maps on the clients. Users have cursors that move on the map. Whenever move or hover event is detected, it's propagated to all connected clients. And users can add layers to the map and shift the layer order, which will also cause the same to happen on all connected clients, but only for the specific map that they're connected to, of course. So that is the essence of this little feature. Now, is this something to talk about to the OGC? Is this really a standardized interaction protocol, or is it an application feature? I can't say with great certainty if map whiteboards have a potential beyond being a feature, but it is something that is fairly interesting to the day-to-day business of many of our clients. People who are collaborating across government departments find this intriguing and have started to sort of express interest in buying it, or what do you say, buy it, integrate it into their solutions. And people who are operating field data capturing applications, where typically one professional is trying to have a dialogue with a non-professional, find this interesting because it allows one person to have a dialogue with another one while they can see the same thing on the map and they can point. One person can create data, one person can indicate his local knowledge while working in the same map. So perhaps they do. The API that we are making, at least, would be open and published as an open specification. No, it's not an open specification, but it will be published as an open thing. And whoever might find it interesting could contribute to it, evolve it, or slaughter it at will. But then again, standardization should not be applied where standardization is not due. So I'm not sure if this is something that we should tout as a standard thing, but I think it is something that is relatively interesting. But the discussion section that we have some time for now, 12 minutes I suppose specifically, is devoted to the value proposition of this. And I think the discussion should be centered on the value creation rather than revenue creation. I mean, we need, if this can add value to someone or something, it's a good. If it can create revenue, that's perhaps interesting, but it's not interesting to discuss in a group. So let's stick to the high road and the nobler goal. What can we do in terms of creating value? And with that, I shall remain silent, I think, and hand the word back to Karel, who will moderate this Chris Wallace style. There was no tokens of obvious violence in the first section, so I imagine this will go well in this last 12 minutes also. So, Karel, yours. Are you still there, Karel?
Sorry, I was mute.
Yes.
So one thing is to discuss about potential areas where this technology can be used. Yes, what is my job and where I am the most involved is farming, and what we see that there were discussed usage of Earth observation data and other data, and farmer is never using directly this data and never processing this data. So there is usually some added value chain of the people who are preparing for data and preparing recommendation. On other side, the most of farmers hate to work with black box and to be not able to understand why they have to do something. So there is really necessary that, for example, advisor who is preparing some recommendation for farmer has the possibility to communicate with the farmer, exchange with him the result, ask him for the comments, and in some cases farmer is telling, okay, I know that this part of the field has different behavior, and please, I would like ask you to change the parameters for example, applying of nitrogen in this field. And this could be the way how there could be communicate. Of course, I think that typical things which could be used is any type of planning, because usually planning is based on the fact that planner is preparing some plan, then it is discussed with public servant. If there is, for example, spatial plan, then it is discussed with people. Usually the way is such that the plans are in the better case visible on the internet. In worst case, you have to go to the office and to draw on the maps what is necessary. For education, I think that it is also very good instrument. We see the potential in some type of the crisis situation where person who is managing the team can online put some information for the user. So there is the number of potential areas where we are thinking, and we are now trying to apply this technology. And generally, we will be interested about your ideas next.
So are you willing to take questions?
Yeah, yes, yes, we can, yes, if you can have some question, we are ready to answer.
Great. Well, I have a question from Brian Haberberger, the Habes in Gitter. He says, you have essentially done everything besides contextualizing your data. Have you looked into producing 5-star data? And he provides a link. So 5-star link data.
I think that Wright is mentioned that we are able to visualize 5-star data. Yes, he mentioned that we are able to read RDF data. Other things is that our metadata catalog, it is based, initially it is based on ISO this 19115 and 1939 standard, but this MITSCA is also supporting metadata in GeoDCAT IP. So these are 5-star metadata. So we are working, we are moving in this direction, and also we have some data sets which are 5-star, like part point of interest, and this is the reason why we are trying to do this. So we are moving to the 5-star.
Okay, thanks. So
I just wanted to say thank you. I'm Brian, and thank you. I'm glad that question didn't catch you off guard. I was actually expecting something different. I'm glad you guys have thought about it.
We have in this Plan for All association, which we have introduced a terrible amount of concepts without explaining what they are here. But In this Plan for All association, we have, among others, a few big linked open data sets, which are, whereof some of the content is, let's say the content varies between 3 and 5 star according to the standard. And we are trying to use, among other things, this technology in a coordinated user-generated content effort to increase the quality of the data to achieve 5-star data. So it is close to home in terms of our day-to-day problems.
Yes, that's good to hear. Have you looked at the GeoJSON LD specification? Because essentially, if you use it, you get 5-star data for free with that context.
Yes, yes. The only problem with every yes, I mean I agree fully. The only problem with standards is that when we work on developing standards, we always become very happy when the standard is finished. But once the standard is finished, we have to populate it. So the population part is not going as fast as the standard. But I think the standard is definitely it's definitely helpful to allow us not to make some sort of massive duplication of effort.
Yes, definitely. And all it would do as it exists is provide that modular support for the GeoJSON, and you guys are doing something much more and supporting other formats, which obviously the GeoJSON LD would do nothing for you for this thing. Your context is much more complicated than just that simple web context for the GeoJSON format.
It's conceivable, but then again, I think what we are doing is probably a great deal less complicated than it sounds like, and it's driven in part by the fact that we have been given an hour to talk about it, and we are very intimidated by the presence of all this greatness in the audience. So we feel the need to wrap it in scientific sort of rationale. But what we're doing is fairly simple, shamefully so in comparison with not much of what you're doing, but it is sort of a connectivity between what happens on the infrastructure level and the business value that we still think is an interesting part of the value chain. But it might not be what could say it might not be on the same precision level as what happens in the great strategic decisions of the world.
Cool, thank you. It was great to see, and that was that's the gist of what I wanted to say.
Very kind of you.
Well, thank you very much for your discussion and presentation.
Maybe, Runar, can you go one slide back?
I think I can. I think that should be within my cognitive abilities. This one you mean?
No. This one.
Yes.
If because this development is now included as the part of so-called COVID-inspired hackathon. It is the event which is running 2 months, and the first what Wright is presented is solved in this first challenge, and the second is in this challenge. So if anybody will be interested to discuss these things with us, we will be very happy to invite you and to continue in the discussion, because this development will continue 1 month, and as we mentioned, we are not only trying to finalize the solution, but we are also looking for different business cases. So if you would be interested, we can share with you more details.
Do you want to share the links, or
in the presentation? If the presentation will be available, these are the links I can send, or I can share links later, because this is the clicking. The presentation will be available. It is possible to go.
If it helps, I just went to the agenda and I was able to download the PowerPoint, so I have those links now.
Okay.
You guys they already have it up. I think. I'm pretty sure that's what this is.
Great.
Okay, I think that if there is no more question, I think that our time is almost over. Runar, you expected that we will be shorter, but seems that we use all our time.
Well, I don't think there's anyone who will cry for this. I think there are people who will fall asleep tonight with their ringing of our voices in their ears and wondering why. So I think we should preemptively apologize to those and thank everyone for attending.
Yeah, thank you for presenting a very interesting application. It looks like it's going to be a winner. So I guess with that, we'll sign off. Unless there's some more messages, there's the links in the chat that if you want to have a look at those. And so we can end the recording, and we will post the recordings as soon as possible, and talks as you submit them. So thank you all for participating today and tonight, and have a good day. We'll see you tomorrow.
Peter, thank you to give us opportunity to present our work. Thank you very much.
Lovely. Thank you.
Yes. Thank you all the presenters. That was a great day.
Thank you very much, and the best of days to you.
Awesome. Good night.
I shall return to pine for the fjords.
Okay.
Okay, bye-bye.
See you. Bye.
Bye-bye.
Bye.